comes to your mind can be used in a mathematical rule. And when we say symbols, we are referring to symbols, mathematical symbols, plus, which is addition, subtraction, multiplication, of course, and of course division. But I think for now we are going to deal with the linear rules, so we won't be having, you know, division of variables and multiplication of variables, because it will end up giving us some nonlinear relations. Okay, so variables, by variables we mean, you know, letters of the alphabet A to Z, but for mostly we use X's for inputs and Y's for outputs. But we can also use letters like M, N, A, B, whatever letter that comes from the alphabet. That won't be confusing to students. We can use it in mathematical rules to represent functions. Now, let's do this small exercise. Find the rule for calculating the output for each input. Given. Use the rule to find M and N. So let's have a look at these flow diagrams. So look at this. This is an incomplete flow diagram, guys. This is an incomplete flow diagram. So our goal is to find a rule. What is happening here? What is happening inside our engine so that we generate these outputs? What if we take a 2, put it into this engine, we process it, we get a 16. What is the engine? What is the rule in the inside block? That's the main question. So how do we find such a rule? So, ladies and gentlemen, there is no specific technique. There's no procedure like a way of, you know, calculating it. There's no precise procedure to follow. It's a trial and error, guys. We have to hunt for that rule using a trial and error method, trial and error technique. Okay, so as you can see, all my inputs, this is what you do. You look at the inputs. The inputs are all positive, and the outputs are all positive, and they are much higher. So what is happening? It means we are multiplying our inputs by a certain constant and adding something that is positive, so that the output is very, very high. Okay, so let's do the trial and error, guys. So we are going to say 2 times 1. 2 times 1. Let's do the trial and error. 2 times 1, I'm getting a 2. But for me to get a 16, I must add, say, 2 times 1, that's a 2. If I add 14, I'll get 16. Okay, this one works for the first output. Let me check. I must check whether it satisfies the second input, maintaining the same procedure that I've just done. What did I do to the first input? I multiplied by 1 and added 14. Let me do that to the second input. 3 times 1, I'll get a 3 plus 14. 3 plus 14, I'll get 17. Is this on my output? The answer is no. So this means that what I'm doing is not the proper process that is happening in this green box. So then I have to try another process again. Let me multiply by 2. 2 by 2, I'll get a 4. 4 plus 12, I'll get 16. Okay, this 12, it just came into my mind so that I get a 16, so that I match the first output. I'm using the first input, trying to map it to the first output. Okay, so let me see. If I multiply 3 by this constant 2, I'll get 6. But I must add the same constant 12 that I added earlier on and see if I get the output. The answer that I get here is 6 plus 12, that's 18. And this is not what is appearing in the output. So therefore, again, this is not a good rule. So you continue to do that until you say, let's multiply. There's a technique, there's a trick, guys. So what you do is, instead of wasting a lot of time to hunt for this rule, what you do is you subtract the 2 given outputs. For example, in this case, I'll say 22 minus 16. I'll get a 6. So the answer you get, usually it is the constant that is multiplying your x inputs. Then, therefore, I would say, oh, it's a 6. The 6 that I got from subtracting my outputs, okay, multiply by x, and x is my inputs. Then, if I do that, I should add a certain number so that I'll get the outputs. So let's look for that number. Let's use the 2 from the inputs. If I say 2 times 6, I'll get 12. 12, so what should I add to get 16? 12 plus 4. Okay, so this should be my rule. So let's see if this is true. 2 times 6, that's 12. 12 plus 4, 16. Okay, it passes for the first input. Let's try for 3. 3 times 6, that's 18, plus 4, 22. Okay, perfect. It matches. It is giving me the correct outputs. So this could be the actual rule. So the rule is y equal to 6x plus 4. So if your rule passes for any two given inputs, then it must be correct. Okay, so let's then use this rule to determine what is m and what is n. So let's start off with calculating m. M is being generated by 8. As you can see, guys, 8 is the third input giving us the third output. So in place of y, I'm going to write m equal to, and then in place of x, I'm going to have 8 plus 4. If I simplify this equation, guys, this is what we call an equation. If I simplify this equation, I'll get the answer for m. So let's do that. M equal to 6 times 8, that's 48, guys. I have a mini calculator in my brain. 6 times 8, that's 48. 48 plus 4, 48 plus 4, 48 plus 4, that's 52. If you are not too sure, you can punch your calculator. So m is equal to 52, ladies and gentlemen. Okay, so let's use this rule again to determine what is n. So in this case, we don't know x, but we know the output is 64. And we said y is our output. So in place of y, we are going to write 64 equal to 6. And where there is x, I'm going to write n plus 4. So this is another equation again, guys, for the last input, and then solving it will give us the answer for n. So 4, we will have to move from the right hand side to the left, and every time a number crosses an equal sign, it changes sign to negative. Okay, this is equal to 6n, like that. All right, and now 64 minus 6 minus 4, that's the answer is 60. 60, guys, equal to 6n. Now, to further solve for n, we divide everywhere by 6, guys. We divide by 6. 6 cancels this 6. 6 into 60, we have a 10. So therefore, our n is equal to 10. All right? You will bear with me, guys. I'm trying to utilize the available space. All right? So n is 10. So n is 10. Right. This is how we generate a rule, and how we use the rule to determine the unknown inputs and outputs, guys. I'm assuming at this moment that we don't have any questions in the comment section. All right. All right. If there is any questions, then I will tackle them as we go. Perfect. Let's go to the next. We also use formulas to determine values, missing values in a table of values. Remember, we did a table of values earlier on. So let's have a look at this one. Describe the relationship between the numbers in the top and bottom rows of the table below. Then determine the values of m and n. Now, we want to determine the rule first, and after determining the rule, we want to use the rule to determine the values of m and n. Guys, I told you earlier on, there is no direct procedure, right, to follow, but we do a trial and error, okay? But to minimize time, what you do is, since we are dealing with linear functions, they are linearly related. So the best way to do it is to subtract any two adjacent outputs to find a constant that is multiplying your x's. Okay, let me say that again. In order for you to find the rule for a given table or flow diagram, what you do is you subtract any two outputs that are next to each other to find a constant or the number that is multiplying your x's. In this case, you take the number that is on the right. Like in this case, I would say -5 minus 7. So here I will say -5, minus and minus becomes a +7. 7 minus 5, the answer becomes 2. Okay, so this 2 is the one that is multiplying my x's. You will see that you will get the same number even subtracting -3 subtracting -5. -3 minus -5. You're going to have -3. Minus and minus gives you a +5. Again, you're going to get a 2. Oh, okay. So my rule is something like y equal to 2x. Now, I need to find what is being added so that I'll generate the outputs. For you to do that, you have to pick the inputs. Let's use -2 and see what we need to add to get -7. -2 for x, it will give us -4. Now, if I have -4, what should I add so that I'll get -7? Okay? What should I add to -4 in order for me to get -7? Yes, you are correct. I must add -3. So in other words, and this minus and plus will give me minus. So I need to wrap this positive and I should say -3. I'm suspecting this should be my rule for the entire table. Let's see if this is correct. Of course, if I use -2 times 2, I'll get -4. -4 minus 3, I'll get -7. Oh, it works for this. Let me try. Before you solve for m and n, you must check whether it satisfies the values in the table. Let's try for -1. -1 times 2 becomes -2. -2 minus 3, the answer becomes -5. Oh, it's true. It's true also for that second column. Let me try for the third column. 0 for x. So it's 2 times 0, it becomes 0. 0 minus 3, the answer is -3. Oh, so my rule is correct. Okay, if you are satisfied, then we have answered the first part of the question, which you are saying determine the rule, right? Okay. I answered a question that was necessary for the second part, but the first part, which is saying describe the relationship. My mistake, guys. Bear with me. I'm trying to explain a lot of things all at once. Describe the relationship in words, in a few words. How do you describe this relationship? As you can see, guys, -2 is mapped down to -7. -1, -5. 0, -3. As we are increasing x values, the y values are also increasing. So that's the best description. So in short, you can say increasing x values will increase y values. Okay, this is the possible description that you can give. Or you can say y is increasing as x is increasing. All right? Okay, I'm sure we all know a number line, guys. When we are on -2 for x, y is -7. And when we are on -1, according to the table, y is -5. As you can see, the y values are increasing. And when we are at 0, the y value is on -3. -1, 1. 2 minus, sorry, a positive 1 minus 1, and a 2 is giving us a 1. As you can see, there is an increase. As x is increasing, y is increasing. So that was the answer for the first part. And of course, finding the rule, you do just as I did here. Now, we want to use this rule to find m and n. As you can see, m is an output, so we replace y with m equal to, in place of x, we replace with 12. So it will be 2 into 12 minus 3. So 2 by 12, that's 24. 24 minus 3, what is it? It's 21. So therefore, m is 21, ladies and gentlemen. And we can use the same rule to find n. But n is being replaced for x, guys. N is the value of x. So therefore, we see, and the value of y is 35. So in place of y, we write 35 equal to 2. Where there's x, we write an n minus 3. And we solve this equation for n. Let's move this negative 3 to the right hand side, and it will add to be 35 plus 3 equal to 2n. 35 plus 3, that's 38. 38 equal to 2n. We divide everywhere by 2, guys, to simplify for n. 2 and 2 cancel. 2 into 38, that's 19. So this means that n is equal to 19. All right, so we have calculated the values of m and n. We have also determined the rule. So this is very, very important, guys. Let's have a look at these exercise. I got these questions from past exam papers, guys. All right, use the table below to draw a graph on a Cartesian plane provided as annexure A. They normally do this and provide you with a graph paper like this. Right at the end of the question paper, they will ask you to draw a graph. So let's do that quickly. We are given a complete table of values, guys. When x is minus 2, y is 5. When x is 0, y is 1. When x is 1, y is minus 1. So let's try to plot these points on the Cartesian plane. This is what we call the Cartesian plane, guys. This measured page in which you have the x-axis, the horizontal line, and the y-axis, which is the vertical line. So let's locate this point, minus 2 versus 5. X is minus 2 and y is 5. Y is 5. Minus 2 semicolon 5. The point is right here. So some teachers prefer to have a cross. Some prefer to have a plus. Some even say you can put a dot. Some do that. Some use a plus. Some use a cross to indicate a point. It doesn't matter. Whichever method you were taught in school, it works. All right. I prefer to use a cross like that. Let's look at the other point, 0 semicolon 1. 0 semicolon 1. 0 semicolon 1. It's exactly here. 0, x is 0, y is 1. It's right here. 1 semicolon minus 1. X is 1, y is minus 1. The point is right here. Okay, so we to make this graph complete, we have to join using a straight line, a ruler, guys. We use a ruler, right? We use a ruler and we can draw a straight line like that. And this is exactly the exercise they wanted us to do. Okay, use the table below to draw a graph. This is exactly the graph. If you are not given the name of the rule here, you just leave it like that. But let's say if they have given you the equation to say y is equal to minus 2x plus 5. I'm not saying this is the rule. We are not going to find the rule. This was not part of the question. But if you are given the rule, then you would say, you write the name of the rule here, the name of the function. Okay. So, but in this case, it was not given. So, since it was not given, there's no need for us to write anything on the graph. Okay. I hope you guys are following. Let's move on to the next question. Exercise number 2. The table below represents the relationship between x and y. What is the value of a? Now, okay, we are running out of time. We're running out of time, but this is very important, guys. So again, in other exercises, you may end up having what we call you may be given sequences, but sequences, they end up being relation. They even end up generating relations. So this is just a mere multiple choice question, but of course you can see that if you try to find a rule to transform inputs x into y, you won't find any, because if you try to say 5 minus 3, you get a 2. All right. If you try to use y equal to 2x plus something, you won't get a proper rule to generate this. But you can see that this problem is not about functions. It's about sequences, numbers that are just placed. So you must try to look for a pattern. All right, for a pattern. Though it's a relationship between x and y, there is a pattern in this particular problem. How can you tell that there is a pattern? You won't find this rule. You can try it on a spare time. You are going to see that you won't find the rule. But as you can see, if I do 2 plus 3, I'm going to get a 5. All right. So if I do these 2 plus that 3, I'll get this outcome. So the same applies to that. If I do 3 plus 5, I must get A. So A should be 8. If I do 4 plus 8, I will get 12. So the answer in this particular question was an 8. Okay, I'm running out of time now, but actually, I had a lot of exercises, but probably let's do this one for the last time. I'm sure we'll be able to cover this in the remaining few questions. Then I'll remaining time, we'll leave a few more minutes for questions. Use the given rule to determine the missing input and output. So this is pretty easy, guys. We are supposed to find what is the value of A. So A is being mapped onto by an 8. So we replace 8 there. So we are going to say for A is equal to, in place of Y, we are going to have A equal to minus 1 over 4. In place of X, we are going to have an 8 plus a 2. So if you do this, you are going to get 4 into 8, you get a 2, minus 2 plus 2 is 0. So A is equal to 0. We can as well do the same for B using the same rule. We are going to say B is being mapped onto 3. So in place of Y, we write 3 equal to minus 1 over 4. In place of X, we write a B plus a 2. 2 comes this side, it will be 3 minus 2, it will be 1 equal to minus 1 over 4 times B. We multiply everywhere by 4, guys, to eliminate the quarter, and it will be 4 equal to minus B. Divide by minus, and you're going to get B equal to minus 4. Okay, so this is going to be minus 4, guys. Okay, it's very simple to use a given rule. And lastly, determine the rule in the form y equal to that something. So as you can see, guys, I told you earlier on, you should subtract consecutive what? Consecutive values. 13. So let's do minus 13 minus 21 to find the constant that is multiplying x. So minus and minus will give you plus. So do minus 13 plus 21. If you subtract, you are going to get an 8. Okay, so you can check, but minus 9 minus 13. Okay, it should be the same. It should be the same. Okay, so now it will be y equal to 8x. Now we want to look for the number that will give us the number. So it's easy to use 0 because if you substitute 0 for x, then you have a 0. Then for us to get minus 5, you are going to subtract 5 like that. So you're going to see that this will be the rule immediately. You can check whether this rule is true for any inputs there. You're going to see that it's indeed true. Then you can use it to find the value of P and Q like we have been doing all along. Okay, because of time, ladies and gentlemen, I'll I will now open this floor for questions. I'm not quite sure, my host, whether we have any questions in the box. We can actually address the questions now. Okay. Any questions? Any questions? I'm not quite sure. We can just unmute and hear the questions from the floor. Do we have any questions in the chat box? All right. Let me just quickly check if we have any questions in the chat box. Perfect. People were saying they like this. If you have any questions, guys, please let me know. Any questions? We have a few more minutes remaining because we're supposed to end at 9. So do we have any questions regarding what we have been doing? Maybe I can address those in the remaining 2 minutes. Thank you for the comments, guys. Yes, people are appreciating. Perfect. Hope it helps you guys. Grade 8 and grade 9 relations and functions are pretty much comparable. You really need this basic understanding in order to tackle your grade 11 and grade 12. Okay, so I'm sure someone benefited. Yes, please come in.
Busiseshes is saying, can you please do the working out for the last question for us? If you can maybe just quickly go through that.
Okay. So perfect. Let me share my screen. I was worried about time. So let me quickly go back. Okay, we were here. So perfect. Okay. Which one was it? This one. No. Not this one. Okay, this one. Determine. Okay, so perfect. People are saying, let's have a look at this. Okay, complete this one. So after finding the rule, we have y equal to 8x minus 5. You can check. You can check whether this rule is true or not. Okay, I think. So if you subtract 7. Okay, minus 18 minus 21, then I will get something like positive that, and I will get a positive 8, correct? Okay, so positive 8. So let's see if this generates. Am I? So minus 21 there, minus 32. Okay. I was trying to rush things here, but it's fine. Let's see. Okay, so we are saying this minus that. 21 minus 18, that's 8. Okay, and minus 9 minus 13. Let's see. I'm trying to check whether this rule is indeed correct, because after getting a rule, you must make sure before you proceed. All right. So minus 9 minus 13. So we are going to get minus 9, that's 9, positive that, minus 13, that's 13, positive 13. I'm getting something 9, 10, 14. Am I getting something less? Minus 5, minus that, and I'll get 4 there. Is this a quadratic or what? Okay. Let's see here the values of x. The values of x are increasing, right? And the values of y are decreasing. Okay, minus 12 to 1 minus, they are also increasing. So it's easy to use this. So this is minus 8x. It could be that There is something not quite right here. -5. Hello, Sinenhlanhla, I think there could be something. What I could do, I could actually replace this. There is a pretty similar question. Okay. I wanted something without a rule. Okay, so let's do this one. I think this is pretty straightforward. I have a careful look at the other question. It could be that the table of values is not properly presented, but it's fine. If you look at this, let's do this one quickly. It's just a simple one to find the rule. Let's do the same technique that I told you earlier on. Subtract the two consecutive values, -3 minus 5. -3 minus 5, it will give you a positive in between, and it will be 5 minus 3, you'll get a 2. Let's check if I will get the same after subtracting two consecutives. I'll have -1 minus 3, minus and minus will give me positive 3. 3 minus 1 will give me a 2. So indeed 2 is the constant. So y is equal to 2 times the x values. But I must add something. So I will use any set of any one column, any single column to determine what is supposed to be added or subtracted. Okay. So by method of elimination, this answer D is wrong and B is wrong. So again, we can plug into -2 here. I will say y equal to 2 times -2, 2 times -2 plus what? So that I must get -5. I want an answer that is -5. So -4. So my answer should be -1. So the missing number should be -1. So -4 -1. So the constant being added to my rule should be -1. So my rule should be y equal to 2x minus 1. So the answer is C. Okay. So this one is wrong. A is wrong, B is wrong, D is wrong. The correct answer becomes D. All right. So, ladies and gentlemen, because of time, I know there is supposed to be another after myself. So I'll leave this time back to the host so that we can be directed accordingly. Thank you.
Thank you, Doctor, for the excellent presentation. As we move to our next session, grade 10, our next speaker is Mr. Samuel Gonzali from UNISA and Astro Science Academy. Whenever you are ready, sir, you can take over since we are rushing over the time.
All right, thank you very much. Good day, everyone. My name is Samueli Bunzali. I'll be your instructor today for grade 10 functions. And I'll be sharing my screen just now, right? So can you guys please give me a heads up when you guys are able to see my screen?
Yeah, you can see your screen, sir.
All right. Perfect. All right. So guys, for the basics, Mr. Hakata, I'm pretty sure it was that, Mr. Hakata presented a fantastic lesson based on functions, right? It was an amazing lesson. So from now, I'm going to be taking over on functions grade 10. So those basics that you guys just learned now are very, very important, right? So today on my side, we are going to be learning functions on sketching of graphs. So the functions that we're going to be dealing with today, right? For grade 10, we're going to be dealing with the, okay. All right, so we're going to be dealing with 4 major functions, right? So the first one is known as what? A linear function, right? So now a linear function, this can be defined as y is equal to mx plus c, right? So whereby m represents what? Gradient. M represents what? Gradient, right? And we know m can be written as y2 minus y1 all over x2 minus x1, right? So that's our gradient, right? So now C represents what? C represents a y-intercept or a constant y-intercept or a what? Or a constant, right? So now that is what? A linear function, right? So in order for us to be able to sketch a linear function, we got two methods. We can use a table method, or we can just use the x and y intercepts, right? So in order for us to sketch the graph, on my side today, we are just going to need the x and y intercepts. So we're going to need the x and what? And y intercepts. And then you'll be able to plot your what? Your function, which I will show you how that works, right? So this is the information that we need on the what? On a linear function. And then the next one that we're going to see later on is known as the quadratic function. Known as what? The quadratic function, which can be defined by y is equal to ax squared plus q, right? Can be plus or minus q, right? So now over here, right, for us creating, this is all we need, right? So over here, our A determines the shape of the graph, if it's going to be facing upwards or downwards. So if A is greater than 0, when they say A is greater than 0, what that means is that the graph is positive, right? It's positive. Greater than 0 means what? Positive. So according to our number line, if we can check quickly, right? This is a number line. We're going to indicate this to be 0. Any number greater than 0 is what? Is positive. So we know our function over here is what? Is positive. And the shape of the graph normally tends to be what? Facing upwards, right? So it will tend to have a smiley face, in other words, right? So now if your A is less than 0, right? Meaning it's what? Is negative. It will tend to have a what? It will tend to have what? A sad face. It will be facing downwards, right? What affects the shape of the graph, right? So Q can be your y-intercepts, or it can also be your what? Y-intercept, or it can be the value of the what? Turning point. The value of the what? Of the turning point. Of the turning point. The value of the turning point, right? Turning point, not point, right? So that's what we're going to be dealing with in the what? In a quadratic function. So now, in order for us to be able to sketch the graph, right? In order for us to be sketching the graph, to be able to sketch the graph for the quadratic function, we are going to need the x and y intercept. So in order for us to sketch the graph, right, we are going to need the x and y intercepts, right? The x and y intercept and the value of the turning point, right? X and y intercept and the value, the coordinates, we can say the coordinates, right? The value of the what? Turning point. Turning point. Right. So once we have those two, the x and y intercept and the turning point, we can be able to sketch out our function, right? So one more thing that I didn't mention over here, right? So the function, like from the start over here, the function is known as a linear function, but the graph itself is represented by what? A straight line, right? So same thing down here. This is a quadratic function, which is going to be represented by what? Parabola. Right. the shape of the graph is known as what? A parabola, right? So now, let's have a look. So now the third one that we're going to be seeing is known as what? Hyperbolic function, right? Which can be defined by what? This general formula, right? So this general formulas over here are also known as your standard formulas, right? So for grade 10, for hyperbolic function, it's going to say that a all over x plus q, right? So now, a all over x plus q, right? So now, over here, let's have a look. So now, a determines the shape of the graph, right? Q represents what? So now let's have a look. So when you are having a hyperbolic function, right, we are going to have asymptotes, right? We're going to have two types of asymptotes over here, right? So the first one is known as a what? A vertical asymptote, VA. We normally indicate by VA, right? So the vertical asymptote for grade 10, right? For grade 10 only, right? It will always be x is equal to what? 0, right? So we normally get this from the denominator over here, where it says a all over x, right? So now over here it will be x is equal to what? 0 for a vertical asymptote, unless stated otherwise, right? And then our horizontal asymptote, we're gonna have horizontal asymptote, which represents y is equal to what? Q. So whatever value is over here, you're going to write it down over there, right? So vertical asymptote and horizontal asymptote. So only on a hyperbolic function, you will have the vertical asymptote and also the what? Horizontal what? Asymptote, right? So now, over here, right? In order for us to be able to sketch the graph, right? In order to be able to sketch the graph, right? To sketch graph, right? We are going to need the x and y intercepts. But before that, the first step, right? The first step is to get the vertical asymptote and the horizontal asymptote. That is the first thing that you need to get, right? Once you are able to get the vertical asymptote and the horizontal asymptote, the second step that you need is to get the x and y what? Intercept. X and y intercepts, right? And then once you're done, you can be able to do what? To sketch the graph, right? So once you're able to get the vertical and horizontal asymptote, right? And then you find the x and y intercepts, and then you sketch the graph, right? So now that is under what? Hyperbolic function, and then the graph is known as what? Hyperbola, right? Hyperbola, right? So now let's have a look on the fourth one. So now the fourth one indicates what? It's known as what? The exponential graph. This is known as the exponential function, right? So this one over here has a general formula, right? It has a what? A general formula which indicates y is equal to a times b to the power of x. It has an exponent of x, right? So once you see an exponent of x, that exponent of x, that indicates this is a what? Exponential function. Plus what? Plus q, right? So now, over here, on exponential function only has one asymptote. It also has what? An asymptote, but only one. Which one? It will be the horizontal asymptote. The exponential function does not have what? A vertical asymptote. Only what? Only what? A horizontal asymptote. So over here, we are going to indicate what? HA. HA indicates what, guys? Horizontal asymptote, right? So, which will be y is equal to what? Q. You guys seeing that, right? So, over here, according to our rules, right? So, over here, y is equal to a times b to the power of x plus q, right? So our b cannot be equal to 0, right? Our b cannot be equal to 0, right? That's part of the general formula, right? B can't be equal to what? To 0, right? So now, in order for us to be able to sketch the graph, right? In order to sketch the graph, right? First thing that we need to get is the horizontal asymptote. We need to get the horizontal asymptote. So since there's only horizontal asymptote, right? And then the second step is to get the x and what? And y intercepts, right? X and y intercept. And then the third step is to do what? Is to sketch the graph. You guys seeing that, right? So these points here are very, very important over here, right? And the exponential function has a shape of a J, right? It has a shape of what? Of a J, something like this, right? You can see something like this, right? Can have something like that, right? So guys, I'll speak more in detail about this, right? Once we're doing the question. So guys, I'll just give you guys a small highlight on what we are going to be dealing with over here, right? So we have a linear function, quadratic function, right? We also have the hyperbolic function, right? And the exponential function. So this is what we're going to be going over for functions in grade 10, right? So now let's have a look. So now we got some questions down here, right? Which requires some little bit of what? Sketching. So can someone please confirm if you guys can see down my questions over here clearly? Hello, can anyone confirm if they can see my questions over here? All right, thank you. So now let's have a look over here first. So first, what I want from you guys when you're working, right, with functions, right? What I want from you guys first is to be able to identify the what? The function, be able to see the function, right? So over here, we are given two functions. We are given what? F of x is equal to 3 all over x plus 1. And the other one, which indicates what? G of x is equal to negative 2x minus 4. Right. So we got two functions, f of x and g of x. So these functions over here are in a standard form, right? So from what I gave you guys earlier on today, right? You can see that f of x is similar to this general formula over here, right? This general formula over here. So this general formula falls under what? Hyperbolic function, right? So we know hyperbolic function has what? A vertical asymptote and horizontal asymptote, right? So now let's have a look. This is sketch 6.1, sketch the graphs of f and g on the same set of axes. So now when you're sketching, the first thing that you guys need to do is find the x and y intercept for both of them, right? So let's split over here and then let's start working, right? So for f of x, we need to find what first? The vertical asymptote and what? Horizontal asymptote. So we're gonna go on and say what? VA. VA indicates what, guys? A vertical what? Asymptote. And for us, guys, we know vertical asymptote is down here, right? So if x is by itself, right? We know this part over here is just going to be what? X is equal to what? 0, right? And then our horizontal asymptote. What is our horizontal asymptote? Is this value over here, as it is. So you're just going to say y is equal to what? Q. y is equal to what? 1. And that's it. So we already got our vertical and horizontal what? Asymptote, right? That's step number 1. Now, step number 2 is to do what? Is to get the x and y intercept, right? So x-intercept, so you're going to say x-intercept, right? X-intercept, you're going to indicate y is equal to what? 0. Are you guys seeing that, right? Y is equal to 0. So now you're going to say y is equal to 3 all over x plus what? 1. So wherever there's y in my equation, I'm going to substitute what? 0. So 0 is equal to 3 all over x plus 1. And then what can I do? I can transpose 1 this side. It's going to become what? Negative 1, right? So it's going to become negative either way. So let me just put down here like that, right? So negative. So this is going to be what? Negative 1 is equal to 3 all over x. So now this is all over 1. Then what do? I cross multiply. So 3 times 1 is what? 3 is equal to what? Negative x, right? Divide this by negative 1, divide this by negative 1, cancel, cancel. Now x is equal to what? Is equal to negative 3. So just like that, right? We managed to get our what? X-intercept. So you can leave it in a coordinate form, which indicates what? Negative 3 is to what? Is to 0. Are we all clear? Right? So now, once we have it like that, now let's get the y-intercept now. So y-intercept, right? Y-intercept is when x is equal to what? 0. So I hope you guys have your calculators because we're going to be working together, right? So y is equal to 3 all over x plus 1. So now, wherever there's x, I'm going to substitute what? 0. So 3 all over 0 plus 1. So I'll advise you guys to take your calculators, right? So I'll punch here with you guys so that you guys can see how this works. So you can say 3 divided by 0. And then you're going to say what? Plus what? Plus 1. And then what do we get? We get math error. Are you guys seeing that, right? We get what? A math error. So over here, you're going to say not what? Not applicable. Are we all clear, guys? We're going to say what? Not applicable, right? You're not wrong. You just say not what? Applicable. Are we all clear? So we get that part over there. So now, everything on this side or on the f of x is done, which is the hyperbolic function. Everything on that side is what? Is done, right? And then we can start working on the g of x. So we do all of this, right? We do all of this before we even do what? We start sketching, right? So now, over here, what do we say next? We're going to say, now let's start this side, g of x, right? So this is a linear function. So the only thing we need is a x and y, what? Intercept. So now, we're going to say x-intercept, right, is equal to, no, sorry. We're going to indicate what? Y is equal to what? 0. So now, we're going to say y is equal to negative 2x minus 4. So wherever this y, we're going to substitute what? 0. So 0 is equal to negative 2x minus 4. And then what do? I can transpose 4 this side. It's going to become what? Positive. So this can be 4 is equal to negative 2x. Then I'm going to divide by negative 2. Divide this by negative 2. So this cancels out, cancels out. Now x will be equal to what? Negative 2. Right. So now I can leave this in a coordinate form. So this is negative 2 is to what? It's to 0. And then I'm going to indicate what? The y-intercept. So y-intercept, right? This part over here, we're going to say x is equal to what? 0. So now I'm going to say y is equal to negative 2x minus 4. So here it's going to be negative 2, x is 0, minus 4. So you can confirm that, guys, with your calculators, right? So this negative 2 times 0 minus 4, that will just be what? Minus 4. Are we all clear, guys? So now, once we have this, we can leave this in the coordinate form now. This is 0 is to what? Negative 4. Right. So now, I have all this information now, right? And guys, remember, no shortcuts, right? No shortcuts at all. So now, once we have all of this information over here, now we can start to plot our graphs, right? And remember, they told us to do what? To sketch the graph of f and g on the same set of what? Of axes. So now we can come down here now, right? And guys, remember to use a ruler, right? Use a ruler, and scale is very, very important, right? So we can go halfway over here, right? So we have something like this, and then now our scaling is very important. So let's look at the values. So it's -3, -4, -2. All right, so it's far more on the negative side. Right, but not a problem. So we can call this part is what? We can call this 2. This part is going to be 4. This is going to be what? 6. So this is going to be -2. This will be -4. This is going to be -6. So this part is 2. This is 4. All right. So this part is -2. This part is negative what? -4. Right. So first, let's start sketching the simple graph, right? Which is the what? Linear function, right? So over here, the linear function has what? So the linear function has -2 is to 0 and 0 is to -4. So x is -2 is to 0. So -2 is to 0 is here. So you're going to put a dot over here, right? So on my side, I prefer a dot, right? But you can put x, you can put plus or whatsoever, right? Whatever is good for you, right? And then y-intercept, we know 0 is to what? -4. And this is what? -4. Then we put a dot over here, right? Then once you're done, only 2 points in order for us to sketch, because we know g of x is a linear function, which is supposed to be what? A straight line, right? So now we're going to come down and indicate what? A straight line, right? We're going to come on and do what? Sketch what? Your function. So there we go. You're going to be having something like this over here, right? Something like this, right? So now, we have something like that, right? So now once we're done, we can try on and sketching the what? The f of x, right? Which is the what? Hyperbolic function. So now, since this is the hyperbolic function, now we got what? F of x. So f of x is equal to 3 over x plus 1. Now, according to information, vertical asymptote. So vertical asymptote, which is a vertical line, they said x is equal to 0. So 0 is here, right? So it's pretty much the y-axis, right? It's pretty much the what? The y-axis. So see, if it's the y-axis, you just leave it as it is, right? And then horizontal asymptote, which is what? Y is equal to 1. Horizontal asymptote is y is equal to what? 1, positive 1. So now you can go on and indicate a dotted line over here, right? The horizontal dotted line. So we know 1 is here, right? So you're going to be having something like this. Going to indicate this horizontal line, right? And then you can name it here. Y is equal to what? Y is equal to 1. Perfect. Now, the next thing that is you're going to need is your what? Your x-intercept and y-intercept. So far we only have the x-intercept, which is x is equal to what? -3. So -3 will be where? -3 is here, right? So now, guys, as you can see, I don't have the y-intercept, and maybe let's say if you do not know the shape of the graph, like right here, guys, everything. I ran out of every information that I had, right? Because I don't have a y-intercept. So there we go, guys. So now, what can you do? So guys, you can use a table method on your calculator, right? So I'll prefer if you guys have your calculator with you, can grab one quickly, have it with you, and then I'll show you guys on how we can use a table method on our calculators, right? So now you're gonna have a calculator like this, right? And then you're gonna go to mode setup, right? You're gonna go to mode setup. Over here, you're gonna press it over here. It says mode setup, and then for some calculators, your table is pretty much number 3, if I'm not mistaken, right? But look for where it says table, right? Look for where it says table, and then you press whatever number indicated over there. So on my side, it says 7. So you're gonna press 7, right? And then once you have f of x, right, you're gonna have f of x over there, and then you can punch in this function. So you're gonna say 3 all over what? And then for us to get x, as you guys can see on this closed bracket over here, on the red side it has x. So you're gonna press alpha x. Are you guys seeing that, right? I get my x. And then I'm going to say what? Plus 1, right? So I have something like that, right? And then it says g of x, so ignore that because I already sketched my g of x, right? So now start. When it says start, you start with the smallest number, right? You start with your smallest number. Which number? Your x value, right? Look at our x value. Which one is the smallest number over here? We can see that our smallest number is negative what? Negative 6. We say start, always remember, start with the smallest what? Smallest x value. So negative 6, right? And we says end with the largest x value, which is positive what? 6, according to my graph, right? And then step in between, to be more accurate, it's fine. You can keep it as 1, right? And then now, yeah, there we go. So now we have this. So now what are we having? So when x is negative 6, y value is 0.5. So we know here is 1, so 0.5 will be halfway over here, right? So when negative 5 is 0.4, okay, it's fine. You can skip that one, go to negative 4. Is 0.25, okay, it's fine. Because remember, I just need the shape, right? So you don't need to put every single point. You don't really need to put that, right? When it's negative 3 is 0, yes, I got that. Negative 2 is 0, is half, negative half. So 1 is here, so negative half is somewhere here, right? Somewhere here. And then negative 1 is negative 2, perfect. We got something over here. And then 0 error. What does that error mean? That error means it's a y what? Asymptote. Are you guys seeing that, right? That error indicates it's a what? It's an asymptote, right? So for us over here, guys, this is a vertical what? Vertical asymptote, right? Now 1 is what? Is 4. So 1 is here, 4 is here. There we go, right? And then 2 is what? 2.5. 2.5. So this is 3, so 2.5 is going to be somewhere here, right? And then 3 is what? Is 2. So guys, only thing you need is the shape of the graph, which is very, very important. So over here, guys, you can see how the curve comes along, right? So now you can construct this properly over here. You can join the points, right? And I'm pretty sure you guys can draw better graphs than me, right? Yeah, so there we go. We're going to be having something like this, right? And then on this side, make sure it's approaching the asymptote, right? Make sure it's approaching the asymptote, but it doesn't touch the asymptote, right? So make sure it's approaching. So we'll be having, okay, hold on. Right, so now we'll be having something like this. Right, there we go. So there we go, guys. We have our function like this, right? So we can name it now. Our f of x. This is our f of x, and then the blue one indicates our what? Our g of x, just like that. We're all clear, guys? And our function would look like this. So guys, the table method is here to guide you for the shape of the graph, right? I'll highly advise you guys to use this, especially when you're working for exponential and hyperbolic function, guys. I highly recommend using the table method on your calculator, right? It's very quick in the exam. So now we have it like that, right? So this is our what? Our functions over here, right? So the other thing that I want to add on over here, right? Even though they didn't ask, I want to add on over here quickly is our domain and range, right? So let's do the linear one on this side, our domain. So let me do this is for g of x, right? So domain, when you're working with domain, right? Domain, we work with the x values, right? When it comes to domain, we work with what? With the x values. So for a linear function, there are no restrictions on whatsoever, right? So for domain, for a straight line, we tend to say that x is an element of all real numbers, right? X is an element of what? All real numbers. Why are we saying that? For every x value, there will always be a what? A y value, right? For every x value, there will always be a what? A y value, right? For g of x, right? So now, range. When we're working with range, guys, when we're working with range, again, we tend to look at what? The y values, right? We tend to look at what? The y values. So now for range, we tend to say that y is an element of all real numbers, right? So now, over here, right? So we tend to say y is an element of what? All real numbers. So for every y value, there will always be a what? An x value, right? So for a straight line, guys, let's not forget our domain and range. For a straight line, guys, it will always be fixed like this unless there are restrictions, right? But if there's no restrictions, guys, this is our domain and range, right? X is an element of all real numbers and y is an element of all real numbers. For straight line, it will forever be like that, right? So now, let's have a look on domain and range for the hyperbolic, right? So the one in f of x, right? So domain, we're looking at x values, right? We're looking at the what? X value. So over here, guys, this hyperbolic function has a restriction, right? It exists everywhere else except where x is equal to what? 0. That's why we were getting error. Are you guys saying that, right? That's why we're getting what? A math error over here, right? The graph doesn't touch there. The graph will be applicable all over, but not there, right? So over here, when you're indicating, we're going to say x is an element of all real numbers such that, right, x cannot be equal to the vertical asymptote. What is the vertical asymptote? Is 0, right? So when you're writing a domain for hyperbolic function, remember you're looking at the x value. You'll say x is an element of all real numbers such that x is not equal to what? To 0, right? So the function exists everywhere else. That's why we were getting for every x value, we were getting a y value. But when we said x is 0, we were not getting a y value over there, right? Why weren't we getting a y value? Because it's what? Is an asymptote, right? So now we got that part, right? So now, let's get the range now, right? Range, we're going to be looking at what? The y values now, right? So the y values, we're going to say y is an element of all real numbers such that y is not equal to what? Y is not equal to the what? Horizontal asymptote. So there we go. Our restriction is here. Horizontal asymptote. What is our horizontal asymptote? Y is equal to what? Is equal to 1. So we're going to say y is not equal to what? 1, right? So the graph will exist everywhere else except where y is equal to what? Is equal to 1, right? So now we're going to be having something like that, right? So that is how we indicate our domain and range for the linear function and the hyperbolic function, right? So let's move on quickly, right? So I was just speaking over here in general, right? So 6.2, let's answer now the questions accordingly though, right? So they said that write down the equation of the asymptotes of f, all right? Equations of the asymptote. When they say equation of asymptotes, is this asymptotes that we got, vertical asymptote and horizontal asymptote. Those are also known as the equations of what? Of the asymptote. So we have them already, so we can indicate them as what? VA is to what? X is equal to 0. And horizontal asymptote, we know y is equal to q, so therefore y is equal to what? 1. And then we're going to indicate our domain for f. So if domain, we have it already over here. So we say domain, right, is when x is an element of all real numbers such that x is not equal to what? To 0, right? Now 6.4. So how does 6.4 work? They say solve for x, right? So they want us to solve for x, and it's for 5 marks, yeah? So 6.4. 6.4, they said f of x is equal to what? G of x. What does this mean when they say f of x is equal to g of x? Yes, we have to equate the functions, but f of x is equal to g of x. In other words, this is indicated as the point of intersection. This is known as the point of what? Of intersection, right? So where two functions meet. So if wherever two functions meet, the functions are what? Are equal. They will have the same x value and the what? And the y value. Are we all clear? So now, let's work. So now we're going to be having what? For f of x, we're going to say this is 3 all over x. We're going to substitute now under f of x plus 1 is equal to what? G of x, which is negative 2, x minus what? Minus 4. Right. So now what are we going to do? So we can transpose this constant this side. It's going to become minus. So we're going to have 3 over x is equal to negative 2x. It's going to be minus, so it's going to be minus 5, right? So now this, you can say all over 1, and then we can do what? Cross multiply. So 3 times 1 is 3, which is equal to x, open bracket, negative 2x minus 5, close bracket. Multiply x inside, so that will be 3 is equal to negative 2x squared minus 5x, right? And then what can we do? We can transpose 3 the other side, right? So this will be 0 is equal to negative 2x squared minus 5x minus 3. So now I have this in a standard form, right? So I have an equation over here already, right? So I can divide it by negative throughout. So I will have 2x squared minus, plus, okay, no, let me do this way. Let me show you guys. So let's divide by negative throughout. So you can divide here by negative 1, divide here by negative 1, divide here by negative 1, divide here by negative 1. So this will be 0 is equal to 2x squared plus 5x plus 3, right? So now, once we have something like that now, right, we can do what now? We can factorize this. You guys see that, right? So we can factorize this one quickly, and then we can get our what? Our factors. So we can say this part over here, right? We're gonna say x plus 1, right? And this part here will be what? 2x plus 3, right? So now once we have it like that, then we're going to indicate this x plus 1 is equal to 0, or 2x plus 3 is equal to what? 0. Then you're going to say x is equal to negative 1, or 2x is equal to negative 3. Divide this by 2, divide this by 2. Cancel, cancel. X is equal to what? Negative 3 over 2. And we have this as our what? Final answers for values of what? Value of x. Right. So this is how we could have answered question what? Question 6, right? All right, guys. We can move on to question 4, right? So we can move on to question 4, and let's see on how that works, right? So over here, what is going to happen? So, okay, let me zoom out. Okay. So now over here, what do we have? So we have question 4, right? So we got question 4. got question 4. So now we've got two functions over here, f of x, right, which is equal to negative 2x squared plus 2, and the other one, which indicates g of x, is equal to 2 to the power of x plus 1, right? So now they're saying defining equations of graph of f and what? And g respectively, right? So yeah, respectively. And now they said that 4.1, write down an equation of the asymptote of g, right? So equation of the asymptote, guys, for g first, guys, we can see that g of x is equal to 2 to the power of x plus 1, and g of x is an exponential function, right? So if it's an exponential function, we know an exponential function only has one asymptote, right? Which is known as what? A horizontal asymptote. So for 4.1, the horizontal, we're going to say now, we're going to indicate here g of x is equal to 2 to the power of x plus 1. Then we're going to say horizontal asymptote is when y is equal to what? Q. Now we're going to take whatever value is over here, which is what? 1. So we're going to say y is equal to what? 1. Right? So we have that. Now, 4.2, what do they want? 4.2, they say that sketch the graphs of f and g on the same set of axes, clearly showing all intercept with the axis, turning points, and asymptote. So first thing, right? First thing that we're going to need is to get ourselves the x and y what? Intercepts and possible asymptotes if possible, right? So now we can split again. So we're going to say f of x is equal to negative 2x squared plus 2, right? So they split this one, this side, right? And this side we're going to be having what? G of x. So now is equal to 2 to the power of x plus 1. So now, yeah, we can have it something like that. So now, over here, first thing, let's look for the x-intercept. So x-intercepts, we know y is equal to what? 0. Right. So f of x, y is equal to 0. So y is equal to negative 2x squared plus 2. So 0 is equal to negative 2x squared plus what? 2. So 2x squared plus is equal to 2. Divide that by 2, divide that by 2, cancel, cancel. X squared is equal to what? 2 divided by 2 is 1. So guys, here we're going to do what? We're going to square root, right? But remember, right? Remember, when you square root a number, right, you get two options, a positive one and a what? And a negative one. So this will be positive or negative. You must remember to indicate that. So now square root of 1, guys. Square root of 1 is 1, right? If you're not too sure, you can confirm that is 1, right? But you should know that when you square numbers, you either get positive or what? Or negative. So x will be equal to positive or negative what? 1. So therefore, x is equal to 1 or x is equal to what? Negative 1. So you can write them in a coordinate form as in 1 is to 0, right? Or negative 1 is to what? Is to 0, right? So we have something like that. Now, let's get our y-intercept. So we also know, guys, our y-intercept is also what? Our turning point. So x is equal to what? To 0. So now, over here, we're going to see y is equal to negative 2x squared plus 2. So wherever there's x, we are going to substitute what? 0. So now we're going to say y is equal to negative 2, 0 squared plus 2. So y is equal to what? So this whole part here is 0. Or you can put it down in your calculator to confirm, right? So you can say negative 2, this is 0 squared plus what? Plus 2. So this is what? 2. So now, once we have that, we can write it down as a turning point. Y-intercept. So this is 0 is to what? To 2. But also, guys, you must remember that your y-intercept is also your what? Your turning point over here. So your turning point is what? 0 is to what? Is to 2. It's pretty much the same. But we're gonna see how that works, right? So we have everything on this side. Now let's sort out everything on this side now. So now here, let's get the x-intercept. So x-intercepts we know y is equal to what? 0. So we're going to say what over here? We are going to say y is equal to 2 to the power of x plus 1. So now this is 0 is equal to 2 to the power of x plus 1. Transpose 1 this side is going to become negative. So negative 1 is equal to 2 to the power of what? X. And thus, guys, you can't solve this, right? So this part over here will be what? Not applicable, right? It will be what? Not applicable. You won't be able to solve this, right? So now we can be able to get the y intercept. So we're going to say y intercept. We're going to indicate x is equal to what? 0. So now what are we going to say? We are going to say that y is equal to 2 to the power of x plus 1. So wherever it is x, we are going to substitute what? Wherever it is x, we're going to substitute what? 0. So y is equal to 2 to the power of 0 plus 1. Now we can put this in our calculators, right? And see what we do, what we get. So this will be 2 to the power of what? 0. And then this will be plus what? Plus 1. And what we get? 2, right? So y-intercept is 0 is to what? Is to 2. We have that, right? So now, once we have all of this, right? Once we have all of this information now we can start to do what, guys? We can start to sketch, right? We can start sketching now. So let's scroll down over here. Okay, that means I'm gonna have to use a new. Right, so guys, always make sure you use a ruler, right? And scaling is very, very important, right? Scaling is very, very important. Your scale is very, very important because your scale is the one that's going to give you a nice graph, right? So let's put this as in, right? So let's say this is 1, 2, 3, and then this is -1, -2, -3. This is -1, -2, -3. This is 1. This is 2. And yeah, we can increase the side, right? Yeah, so now this side is what? This is 3, right? So now this is your x, this is your y. So now let's go. Let's start with the f of x, right? The quadratic one. So we can see, guys, we can see over here, we can see, guys, our a over here is what? Is negative. So we should know our graph is facing what? Downwards automatically, right? So now let's get our x-intercept. So our x-intercept is 1 at -1. So 1, we're going to put a dot over here, and what? And -1, right? We have that, right? And then what else? We have a y-intercept of what? 0 is to 2. So y-intercept is here, right? So we also know this y-intercept is also a what? Our turning point, right? So it's also a what? Our turning point. So just from this, guys, these 3 points, therefore, you can be able to do what? To sketch your what? Your graph. So you can start over here. Right. So there we go. You will have something like that. Are we all clear? So you'll have something like that. Right. And then once we are done, we can move on to this side now, right? So g of x. So the first thing on g of x, guys, they gave us what? We need to get the what? Asymptote first. So what type of asymptote? Horizontal asymptote. So we indicate that one first on our graph, right? Horizontal asymptote. So horizontal asymptote is here. So we're gonna indicate a vertical dotted line. Hold on. Right? So we can indicate a vertical dotted line first. positive 1. Right. Once we have that, this is y is equal to 1. Right. So now, let's get the x-intercept. So we don't have a x-intercept, but we only have a y-intercept, which is 0 is to what? Is to 2. So we have it over here, all right? But now, guys, we only have 1 point and we do not know the shape. We're not sure about the shape. This is where your table method comes in, right? This is where your table method comes in. So you grab your calculator quickly, right? You're going to go to mod setup, table, right? And then for f of x, you're just going to put in the same function, right? Don't worry about what they have for f. You just need to put in what you want to work with. So 2 to the power of what? Alpha x, right? And then you're going to indicate what? Plus what? Plus 1, right? G of x, don't worry about that. Just going to press equal to again. Start with the smallest x value. So which is what? Over here, according to us, is -3, right? And then the biggest one is 3, right? And then step is 1, right? So now what we have, so -3 is 1,125. So it's close over here, somewhere like this, right? And then -2 is 1,25, so it's somewhere there, somewhere here, right? And then this is 1,5, so 1,5 is here, right? And then 1 is 3. 1 is what? Is 3. So from here, guys, this should be enough points, because the only thing you need is to know the shape of the graph, right? These points here will guide you to get the proper what? Proper shape, right? So once you have that, you can, right? And then you can come down along. Hold on. As you can see, guys, it has a J shape. Right. So didn't pass through here, that's fine. And you can indicate it down here. Right. So we have this. You guys see that, right? We have this shape over here. All right. So now we can name them along. So this is what? Our G of x, and this is what? F of x. Right. So before we move on, let's discuss our domain and range, right? Which is very, very important. So now, domain and range. Let's start with the f of x. So f of x is here, right? So for quadratic, right? For a quadratic, we are going to indicate domain. Domain, guys, we're looking at what? The x values, right? Domain, we're looking at what? X values. So for every x value, there's always going to be what? A y value. So x is an element of what? All real numbers. Are you guys saying that, right? For f of x, which is a quadratic, x is an element of what? All real numbers. And then range, we're going to be looking at what? The y values, right? We're going to be looking at what? The y values. So now, the y values for our function over here, for our range, we are going to look at the y values, and we're going to looking at the value, the turning point. Look at the turning point, right? So first, what is the turning point over here? The turning point is what? The coordinates of the turning point is what? 0 is to what? 2. We are going to focus on the y value of the turning point. Are you guys saying that, right? So this graph only exists when it's 2 going downwards, right? When it's 2, right? When the x values is 2 going what? Downwards. Because if you say 3, the function f of x does not exist over there. Are you guys saying that, right? The function does not exist when the value is above what? Above 2. So it only exists when the values are what? Are 2 and less than 2. Are you guys saying that, right? That's where the function does what? Exist, right? So you can't say y is an element of all real numbers for a quadratic function, right? You can't say that. What are we going to say? We are going to say that y, right, is less than or equal to, right? Less than or equal to what? To 2. That's it, right? Y is less than or equal to what? To 2, because that's where the function does what? Exist, right? So it only exists when it's 2 and the y values downwards, the values that are like 1, 0, -1, -2, all the way down to negative infinity. Are we all saying that, right? So all in short, you can say that y is less than or equal to what? To 2. Why are we saying equal to? Because it does touch a 2. Are you guys saying that, right? So you're just going to indicate that. Right. So now, let's indicate our domain and range for g of x. So g of x, right? G of x, we can say domain, we can say that for this one here, for g of x, for exponential, right? Over here, the values do exist, right? From negative infinity all the way to positive infinity, right? We're gonna say x is an element of what? All real numbers. Are you guys saying that, right? X is an element of what? All real numbers, right? So, but the range now, right? You can see the function is only applicable above 1, which is the asymptote. Are you guys saying that, right? Above what? 1. And how do we write this? For exponential, guys, this is how we're going to indicate. We're going to say y is greater than. We can't put equal to because it does not touch the asymptote, right? We're just going to say y is greater than what? Than 1. Are you guys saying that, right? So that's going to be our what? Our range. Y should be greater than what? Greater than 1. Right. So that will be our domain, and this will be our what? Our range. Right. So I hope you guys enjoyed this lesson. I'm going to stop over here for today. Thank you guys for attending, and I hope I'll see you guys next time, right? So open for questions, guys, that you guys want to ask or confirm. Anything you guys can ask me now, right? Any questions?
Thank you, Samuel, for such a nice lesson. If anyone has a
Yes.
question, can they please write on the comment section due to the time?
Or they can unmute if possible, if you guys don't mind.
Okay, just a few minutes because we need to move to the next speaker.
All right. All right. You're asking how can we determine the range and domain? All right. Okay. So for which function specifically are you talking about? Because over here I did indicate for almost all of them. So can you please clarify on that one day? Which part are you talking about? For exponential and hyperbola. All right. So for exponential, right? So for exponential, I did do this one over here, the one that I just completed right now, right? And I did indicate that for g of x, which is our exponential graph, right? I indicated that domain is when we're looking at the x value, and we say that x is an element of all real numbers. So for every x value, there will always be a what? A y value, right? So for what? For exponential, right? But now for range, the range, as you can see, guys, the function only exists when it's above what? This asymptote over here. Are you guys saying that, right? It only exists when it's above the what? Asymptote. It doesn't touch the asymptote. So we are going to say that y is greater than what? Greater than what? 1. right? When y is greater than what? Greater than 1. So now, greater than 1, right? So that will be your range for what? Exponential. And then we did indicate over here the domain and range for hyperbola, right? The domain and range for hyperbola is over here, right? The one in red, right? So domain, we indicated that x is an element of all real numbers, right? Such that there's a restriction over here. So for domain and range for hyperbola, it all depends on your vertical and horizontal what? Asymptotes, right? And you guys be very careful on how you write. It's very, very important, right? So domain, we indicate that x is an element of all real numbers such that x is not equal to what? 0. So you'll get for every other x values you will get, but not for one. For what? For 0, you won't get a y value, right? That's why when we were working on our calculators, we ended up getting our math error, right? So now for range, range, we say y is an element of what? All real numbers such that y is not equal to what? 1, right? So all of this, guys, it all depends on your what? On your vertical and horizontal what? Asymptote, right? So in order for you guys to be able to identify the horizontal, the domain and range for hyperbola, guys, it all depends on your vertical and horizontal what? Asymptote. Are we all clear? Right? So guys, due to time, right? So guys, if you got any questions, guys, you can send me an email, you can contact me, right? So I'll be willing to help. That's also fine. But guys, due to time, guys, we are going to stop over here for today, right? So thank you guys to the team. Thank you for giving me this opportunity. And I'll be looking to see you guys next time, right? Take care.
Thank you so much. Thank you.
All right.
Okay, so as we move to our next speaker, Dr. Desando will take over with grade 11 functions. Then you can take over, sir.
Hello, good morning. Can you hear me?
Yes, we can hear you, Doc.
Okay.
Okay, thank you.
Good morning, everyone. Let me try to share my screen. Okay. Can everyone see my screen?
Yes, you can see your screen.
Thank you very much. Thank you. So, before anything, maybe I should talk. I should talk about myself. My name is Mafuya Lanri Dasund. You can call me Mafuya. Okay. So, I'm a PhD in algebra, and I'm from Republic of Benin in West Africa, and I work in Ivory Coast as a lecturer in mathematics at the University of Man. This ma is the name of the city. So it's not the University of all men. No. Okay. So this is just a slight clarification. Okay. And you can email me on if you want, or any other email address like that one too. Yahoo.com. Okay. So thank you. So today we want to talk about functions, and talking about function, we need to quickly before starting everything. So I want to let you know that if you want to ask questions, please just unmute yourself and or maybe the like you can while I'm teaching, if you want to ask question, please unmute yourself and say, oh, I have a question, and then we will carry on like that. So I just prefer to receive the question as soon as we are moving. So we will be less how to say focus in doing calculation. We want to do mathematics such a way that when you will be out of this class, you will know, you will be able to identify what are function in the real world, and then try to 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 have your own example of function, and maybe later you can read the remaining in books and any how to say any books that talk about function. So and then also I want to apologize for my accent. I don't have South African accent, and I'm not good in imitating South African accents. So so I'm sorry if you can't hear me well, or maybe I pronounce the word and then you can't really identify which word I'm talking about. Please unmute yourself and say, "Oh, can you write down the word that you just pronounced now?" I will write down. Okay. So just try to be straight when you are asking your question, and then I will be nice enough to answer your question. So then we start right away talking about function. We need to know what is a set, and then define what is a set, give some example, and then in number two, talk about the characteristic of a function. And inside this characteristic, we have the domain, the codomain, or a range, and then the mapping or the graph. So then next, we have all of the tools now combined together to define what is the function, and then give some examples and counter example, because sometimes you might feel like, okay, this is a function, and it might not be a function. So you can now build like, what is a function and then what is not a function. So what look like a function but is not really a function yet, it needs some more how to say a requirement to be a function. And then now we will go to type of functions and then talk about polynomial function, trigonometric function, square root function, hyperbolic function, if time given. But at least if you can move to the point 3, it's okay. Okay. So this is what I planned for the coming 40 minutes. And if you are okay, we move on the first point. Okay. Question there? No question there first? So guys, feel free to ask your question. There is no dumb question. There is no nonsense question. And please, so I would like to beg you to ask questions as much as you feel uncomfortable somewhere. Please ask questions. No one going to target you for the type of question you ask or whatever. Or maybe maybe each 5 minutes I will go to the comment section and see whether there is a question type in the comment section there. Okay, so we move to the point 1. Sets. So we understand a set as collection of objects. Finish. Collection of objects. We don't care what are the objects. As an example, I can say the set of or I can say a currency note. And then in this set, we have what? A set of collection of South African currency notes. Okay? We have 1 rand, 2 rand. If there is a note of 2 rand, is someone in the comment section to tell me if there is a note of 2 rand? Yes or no? I want a class to be more interactive. So if I write something which is not good, just let me, okay?
Yes,
So maybe 5 rand, 10 rand, 20 rand, 50 rand, 100 rand, and 200 rand, something like that. So this is a set of South African currency notes. Another example, we can say a set of phone brands. Okay, so we have Nokia, what? Honor, Huawei, Samsung, whatever. As soon as it's a phone brand, it's an element of the sets. Okay. Another example, set of integer, which is what? 0, 1, 2, and so on. As soon as it's an integer, it's in the sets. You know that? You know that? And also you know that. Set of real number, rational number, and negative and positive integers. So someone, is there someone who has question? Oh, let me try to see the comment section. How can I see the comment section now? I think. Yeah. Comment section. Okay, thank you. 10, 20. Oh, nice. 10 cents, 20 cents, 50 cents, round 1, R2, R2 coins. Okay. Thank you. Thank you. Busisi way. Okay. So thank you very much. So thank you. But let me come back to the notes. So So we can carry on. So then we know what is a set, and we gave already some examples. Okay? And then we want to talk about characteristic of a function. So to talk about the characteristic of a function, we need to know so talking about function, we have the domain. And then codomain or range. So on the domain is the set. The codomain is also a set. And then the function is the mapping between the range, the domain and the codomain, or the domain and the range. So talking about a function, we need to know three objects. Two are sets, and the third one is the mapping or the graph. So function we hear behind this word a domain. And code, okay, I think range, that will be easier for you. And then the mapping. So the question is, first, anytime you want to talk about function, you need to differentiate the domain and the range. You need to identify what is the domain and what is the range. You have to separate them. And then secondly, the graph or the mapping. Okay? Someone want to ask question? Please. Yeah, go ahead, ask your question.
Mommy and
Okay.
Daddy, I don't know what they're doing.
I'm hearing.
What you thinking? What you thinking?
Hello? Questions? Okay. Maybe I'm not hearing the question, so we continue until the person is ready to ask the question, okay? So the question is, we already know that domain and range are sets. So the mapping, how the mapping look like? So the mapping is the process that map an element of the domain to an element of the range. And the mapping need to have some characteristics, some specificity. So, and this will allow us to define what is functioning properly, because the mapping is for each element the domain, there is exactly one or zero elements in the range What does mean? The mapping try to fix one or zero element in the range for each element in the domain. In another word, if you want to do some plotting, let's say here is a domain. An element of the domain has maybe cross. And here is the range. Element of range are small circles. I don't know the number of them. I don't care. What matter is the mapping. I take this element, I map to that one. This element to that one. This one 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 to that one. And I said, oh, this is a function. And it is true. Because for each element, I mapped that element to I want to, okay. That's what I'm looking for. So for each element here, I map this element to one element or zero element in the range. So this is a domain, this is the range. So I'm mapping element of the domain to the element of the range. Okay? So a function, if I choose one element of the domain, it has a correspondence to into the range, but if this correspondence exists, it is exactly one. Or it does not exist, zero elements. So we cannot have this picture, something like that. And call it a function. This can't be a function. Why? Because this element, it has two correspondents in the range. So failed to be function. Okay? If we choose any element in the domain If this element has a correspondence in the range, the correspondence must be only one. Or this element doesn't have a correspondence in the range. Let me go to the comments and see whether someone leave down some comments. Questions? Comments? No question in the comment section. So continue. So now we see how the mapping works. For any element in the domain, if this element has a correspondence in the range, the correspondence must be strictly one. Or if this element doesn't have a correspondence, then it's 0. Okay, so this is a proper definition of what is the function. So a function is a correspondence between two sets, exactly two. The first is called domain. The second is called range, such that for there is exactly one or 0 elements corresponding to in the codomain, in the range, what we need to understand by a function is we have two sets. One is called a domain and a codomain or a range, the second one. And then it is a correspondence. And then for any element of the domain, if this element has a correspondence in the range, range must be E somewhere here. It must be exactly one, or it doesn't have elements corresponding to into the range, which is it has 0 element corresponding to the range. Then with this definition, we can easily now identify function everywhere. And I want to give some real world example. Before I go for example, let me go to the comment section and see whether there is some question waiting for me there. I don't know what's going on. Okay, comment sections. Yeah. Oh, how the circle you were drawing are related to the functions. Thank you for the question. Wonderful. I think you are talking about this circle, right? Or the small one? First, this is the way I represent a set. So we have two sets. And the D here means the domain, and the R here means the range. And then inside the set, we define set as a collection of objects. Objects inside the sets, in the domain, I call them cross. These are elements inside the set. And then in the range, elements inside the range, I call them small circles. Because I just named a random set, I don't mind how the elements look like. I don't know the form of the element. I just assume that, oh, elements are stars or are cross. It can be a set of what? Of the year old of student in your grades. And the one can be the set of your size. Okay? Or your weight. If you go on the scale and you weight yourself, 20 kg, 40 kg, 100 kg. Okay? So I don't mind how they look like. I just want to identify that I'm having two sets. One called the domain, the second one called the range. In the domain, there are elements, and in the range, there are some elements. And I just named the elements star or cross and circle. Are you happy with my answer? Let me see. Thank you very much. Cross or Penny. I don't know. I'm sorry if I pronounced badly your name. Okay, please keep asking me questions. Okay, I'm happy if you are asking me questions. Then what I'm doing makes sense. If you have your question and then you refuse to ask, you are making me uncomfortable. Okay, sorry. Make me comfortable. I want to see your opinion of what I'm writing down here. Right now, we are doing mathematics without big challenges, big stuff. I just want to do mathematics naturally. And when we go for some example that you all know, okay? So we define what is the function now. We have two sets, okay? And then we are mapping elements between these two sets. One is called domain, and another one is called the range. And then the mapping is if we choose any element in the domain, this element has one correspondence to in the range or zero correspondence. If it has correspondence, the number must be one, no more than one. Okay? And then we want to give examples. And then again, I want to draw some circles. So I choose the set of girls and the set of boys. And then I want to correspond them. Okay? Let's maybe reduce our set consideration to the set of girls in your in your groups now, in our groups here now, and then the set of girls in our groups here now. And then we want to imagine, so this is an imagination. What can be the maps, the mapping here? We can say, as an example, we want to map them together. What example can we give between set of girls and boys? An easy example is a marriage. I want to marry a girl with boys. Okay? It's a kind of function for every girl. If she's married to the boy. If not, she's not married yet. This is a function. And we all know. Okay? So the domain is a set of girls. The range is a subset of girls, boys. Okay? Okay, let's flip the domain with the range. So I choose now boys, girls. And I want to see I want to marry them for a boy. How many possibility of girl he can marry to? And I said, oh, it depends. Somewhere like in West Africa, you can see one boy married to 4, 5, 10 girls, 2, 3, more than one. So this way can't work because he can be married to 2 different girls in some area. He can be single forever. Yes, but this possibility doesn't work. So this is one natural example that we have to put in to a quote. But what society agreed on is for a girl, if she's married to a boy. Okay? So I don't want to go to debate into where there is a possibility for a girl to have more than one, or just the common one that the society agreed on. We just keep it like that, okay? This doesn't have any things. So I want to see if there are some questions. Questions, please. I'm looking on the chat. No question yet. If questions are coming, please type your questions. I want you to see functions everywhere. Okay? Okay, another example is okay. We choose the set of real number. And as a domain, we go to the set of real number as a range. And for any element in the set of real number, we want to correspond to another real number. What we do that correspondence? Oh, we double the element choose and we added 1. What does mean? Means that 1 is corresponds to what? 2 is corresponds to what? 1 is corresponding to 2 times 1 plus 1, which is what? 3. 2 corresponds to 2 times 2 plus 1, 5, and so on. So any element x, the corresponding element to x is the double of x, and we add 1. So if x is fixed, this corresponding element is also fixed. No change. This is a function. Maybe I call it function. So this is a function. I call it f. Okay? So the range and the domain are the same sets, but for each element in the domain, there is his corresponding element in the range. If you want me to do one more, for f is 3, 3 is corresponding to 7. Oh, let me write 7 like the way English people write 7. So because it's 2 times 3, which is 6, plus 1, 7. Good. Questions. Let me go to the question section, comment section, and see whether there are some questions waiting for me there. Yeah, no question is waiting for me here. Please, I'm sure you have questions. Please ask your question. Do not be silent on your question. Okay? I suppose that I'm still on call and you can hear me. Okay? Okay, thank you. So now we continue. We continue with the mapping. Okay? And I want to give you two functions. And I want you to tell me if they are the same or they are different. The first one, I take the function f, the domain is R, the codomain is R. For x, I square the x and I add 1. The function g is, the domain is R, the codomain is okay, sometimes is 0 infinity. For x, I choose the square plus 1. Question. F is the same function for f and g. Are the same function. Are they the same function? Yes or no? Let me see the comment section. Good question. What is the difference between the domain and the codomain? Wonderful question. Yeah. What is the difference between the domain? Okay. Okay, I will go first with the difference between the domain and the codomain. So the domain and the codomain are both sets. They are sets. But the domain is the starting set. And the codomain is the ending set. So is the input domain is the input, and then range is the output. If you want, I will it is the input element, and then the output element is the codomain or the range. So this is the difference between them. So let us take maybe an easiest example, another example to specify the difference. Yeah. So we take the function go to a trip with car. Oh, okay. So with a specific car. And then I said the domain is squared. And the range is the number of miles you travel to. You see the difference now? So I choose my car, I put some gallon of fuel inside, and then with this gallon of fuel, I travel for some miles. So the domain, we supply to our car fuel. And then the range, we got some distance that we will travel with this amount of fuel. Is this meaningful for you? I didn't read your name, but the person who asked, the person who asked the question on the domain. So here is the domain, and here is the range, or the code domain. In the same name, they are both sets. The set of gallon of fuel and the set of miles that we travel. Let me go to the comment section and see whether there are question waiting again. So the paying calls, the difference is the domain is the set of supplier, the element that you supply, and the range is the set of the how to say what you get in the returning. Okay, let us say playing a lottery. You want to play a lottery, you pay the lottery card with some coins or some notes, some money, and then use cash. Either you win or you lose. If you win one prize. You can't win 20 prize at the same time. No. Okay? So then we're back to my question here. Someone told me they are the same function. And I want to tell you, if you want to evaluate what is the function, let me add one more line. And I call it H. And I go from R to integer for X. And then I'm asking F. Is they are all equal? What I want you to know here and to pay attention on by giving you these tricky examples is to see whether two functions are the same is 3 steps. First, the domain. The range and the mapping. Here, the mapping is the same. Everyone agree with me? Is the square of the element plus 1. It's the same mapping. So, same mapping. The domain, all of them are the same. N is the range. If these 3 elements are not the same, the function is different. Okay? If these 3 elements are not the same, the function are not the same. Oh, okay. 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 range and domain is the same thing. Range and codomain is the same thing, okay? So, thank you. So, no difference. It's the same, okay? And they are both sets. So, I was talking about domain of all of these three functions, they are the same. R, R, R. The codomain are not the same. The first one is R, the second one is 0 plus infinity, and the third one is integers. The mapping is the same. All these three elements must be the same before we say the function is the same with them. Okay? So I think I use almost all the time that I'm having, but I want to hear from you because there are some stuff that we didn't talk about. Polynomial function, trigonometric function, square root function, hyperbolic function. The polynomial function, what I can say is, I don't want to confuse you much, but if the function look like what? A times x to the power n, and then we add a times x to the power n minus 1, but it's an minus 1, and so on to 1, a0. This is a polynomial because we have, if you have what, I don't want to use this letter, so we have b times f to the power p. This is monomial, and polynomial is many monomial. So many, I choose many of them. Okay? So many, at least two monomial is already a polynomial. A trigonometric is the function that use cosine, so cos function, sine function, tangents, and so on. Any trigonometric tools that you know as a trigonometric function. Okay? So let us stop there. I don't want to waste time, and then, but I'm open for some questions. So please, question if you have some question. I'm looking for the chat box. No question is asking. At least someone can unmute himself and ask question. Okay, I can't force question, but at least if I have to do an upshot, we talk about function, but the word function, we have three words embedded to that word. The first one is the domain. Is the domain. The second one is the range. And the third one is the mapping. And then the mapping map element of the domain to element of the codomain. Okay? So then from here, anywhere you go in your real life, you can identify function everywhere. Okay? You just have to be clear enough. You need to differentiate what is the domain, what is the range, and then what is the mapping. Okay? So you need to have these three elements to say we have a function. Okay? So this is just what I want to tell you. So if you go to your books, things are well written structures there. you can understand and digest things there easily. Okay, so I want to thank the organization for everything that you guys are doing. You are aspiring people like me in West Africa, and probably from next year, I will initiate something like that for our new generation to 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 try to put some efforts in mathematics, and then hopefully Africa will be the root of for mathematics in the coming years. So let me look at the chat question. If there's questions. For exponential, what is the easiest way to how to draw one? Drawing the function. If you want me to talk about 1-2 words, because I was not specific while I'm teaching. If you want to draw function globally, because I talk about domain and range, so the horizontal line is the line of domain. The vertical line is the line of range. And then everywhere else is the mapping now. So the mapping must be viewed in between one element in the domain and then the corresponding element in the range. But the easiest way to do to draw exponential function, because the exponentials, the domain is R, the range is zero infinity. Okay, so then the domain is R, the range is 0 to infinity. So you don't need this part. So you know that the function, if I'm drawing, it will be somewhere here inside this part, but never here, because the range is positive. And then the first thing is 0. The image of 0 is 1. So it goes full by 1. And then you know that it's increasing function, all of these characteristics. So later you will learn how to differentiate, to appreciate the sign of the deviation, and then know that how the function flow, how the asymptotes will look like. But you know that it's something that will look like that. This is the exponential, the logarithmic function. You know that it's 0 plus infinity, but at least at 1 is 0. So it looks like that somehow. Okay. So I don't want to be specific where I'm teaching. I just want you to know how things look like in the brain, and then you'll be able to identify function everywhere and in the society. So thank you very much. Question is the question. I don't want to take much time. Thank you.
Thank you, Doc, for sharing your knowledge with us. You're much appreciated. So as we move to our next session, grade 12 functions, Dr. Chin will be taking us through the functions. You may take over, Doc, whenever available.
Let me stop sharing.
Thank you, Chair. I guess, Co-Chair, you can see how I look like a little bit. Students, I'm grade 12. I'm dealing with grade 12. Welcome to this class where I'll be talking to you about functions. The grade 11, some of you are still around. I hope you had a good time with the previous presenter. But I want to start by putting something for you on the chat. For those of you that are watching from Microsoft Team, I know the people that are being broadcast to, you will not see that, but I'll probably share that document towards the end, which is a study guide that corresponds to your curriculum that I draw from for the material I'm going to be sharing with you. So I want now to go to my PowerPoint. Yeah, so you can see my screen. I will keep my video on for a few minutes, and then after that, I will take my video? Or would you like me to keep my video on for the whole duration of the lectures? That's also okay with me. I don't mind. So I want to talk about functions, and I want to focus more on quadratics and hyperbolic functions, okay? So my name is Jean-Médard Autrier. I work at the University of KwaZulu-Natal as a senior lecturer of applied mathematics. I also do some work in the leadership, but let's leave that. We want to talk about science. We want to talk about maths, grade 12. I want you to be well prepared when you go for matric, that the section on functions, all those marks, you can easily get them, because as an educator, as a teacher, I think when we assess you, it's not about us giving you marks. You take the marks that you like on the question paper, depending on the interest that you have for what you're doing. But I want to start my class by pointing out this quote from Tata Madiba, who is the father of the nation, Nelson Mandela. Education is the most powerful weapon that you can use to change the world. And I've translated that in isiZulu, in isiXhosa, and in Afrikaans, depending on who is watching or listening. So please, I really want to tell you, before I dig into the math of functions, that you are in charge of your education, you're in charge of your learning, and you want to get your hands dirty, you want to get involved. So I can teach you maths. You can spend your whole day listening to me teach you, talk to you about math. You see me doing maths, but it's important that at some point you sit down and try these problems by yourself. You need to give in the hours to practice, because it's through practice that you'll be perfect and that you'll be writing your exam paper at matric with a smile on your face. So taking in charge of your own education is very, very important, because that will allow you to be successful, not only in your studies, but being successful in life. Okay, grade 12, at your age, you're already a young adult, you're looking forward to build your own life, to build your own career. You should be thinking about that. And education, that's what we're doing now, mathematics. It's a powerful weapon that you can use to change your own world first. So you want to be good, you cannot pour from an empty glass, okay? So you want to be good at this math so that next year you can be also presenter, or the year later when you pass your degree. So that was a little bit about the third degree, or a little bit of piece of advice. I hope you find that useful. So let's move on, okay? So what is a function? Simply put, a function is defined as a relationship between values where each input value maps to one output value, okay? So the other colleagues talk to you about function, but in general, you will have, like, let's say you have a set here, A and B, okay? So you have input value, the one on the left side, and then you map it to another value there, and so on. You notice that in your previous class, for those grade 11 that are still with us, this set sometimes was a set of real numbers and the real numbers, and you can map it using x squared and so on. The key thing for function, for a correspondence like this to be classified as a function, it's very, very important that each input value map to one output value only. If it maps to more than one value, it's not a function. That's why for you to recognize that something is a function, we use this vertical line test. The vertical line test that I have here, I need to have we can use a vertical line test to recognize if something is a function. Vertical line test, you can see here. So you draw the graph and then you move your ruler, you put it vertically and you pass through the graph of the function. If it touches the function more than once, the graph more than once, then it's not a function. So the graph that you see here, it's definitely not a function. Okay, so that's how you check if a correspondence is a function, right? Grade 12, I hope that's clear. So in the class of functions, remember it's a relationship, we have functions that are called to be one-to-one. A function is one-to-one if for each input value, you have one and only one output value that corresponds to your function. Like this is the graph of a straight line. It's a one-to-one functions, okay? But you can also have many-to-one functions, like what we have there. This is the plot of x squared or x squared minus 1. So this is the plot of x squared, and you can see for the value -1 and the value 3 here, you have exactly the same y value. So this is many-to-one. It's indeed function, because if you do your vertical line test, the function that I'm showing you on the right will be recognized as a function. Okay, so those are a few types of functions: one-to-one, many-to-ones. Okay, so what are the different type of functions that you deal with in life? So if you're focusing, these are the functions that we'll be dealing with. As I indicated, my class today will focus more, because I only have almost 45 minutes. So I'll focus more on parabola and hyperbola, but exponential graphs, you can touch on that, and straight line graph, you can touch on that. And by the way, it was important for me that I tell you, I think I've shared that in the chat. Yes, I've shared the material that I'm using in the chat for you guys. Okay, there is a link that I share for you that you can use to see all the data and look at how, because in that material, in that study guide, you also have straight line and you have exponential graph. Okay, so let me just tell you, straight line, you draw it like that, it's a straight line. Okay, parabola will always have that shape or that shape, depending on the a that appear there. Hyperbola, it's a function that is like that, or in some cases like that, like that. That's for your hyperbola. And for exponential, the previous presenter in grade 11 showed you how you draw exponential, but the same idea, exponential, is something that goes like that. So technically, you should, grade 12, being able to quickly sketch those key functions: straight line, parabola, hyperbola, and exponential graphs. There are many other graphs, like trigonometric ones and hyperbolic ones, and so on, other things. But this is the one we will focus on. And what you see here is that sometimes those graphs that I sketched for you can be shifted up, down, left, right, and then you get a more general expressions like the one that I just circled there at your bottom left. So those are the different type of functions that are out there, but our focus will be on parabola and hyperbola. Grade 12, I'm showing you some general thing about functions. I won't spend too much time on that. After that, we'll get our hands dirty and be looking at questions, because I know we are here to support you, to prepare you for metric. And it's important that you know how you solve real questions that will be coming around in metric, okay? So I will take you to those examples and those questions and guide you through how the solution is achieved, and recall all the theory, so that you will be well equipped at the end of this class to be able to say, throw to me any functions, parabolic or hyperbolic, any questions related to those. I will get all the marks that you allocate to those questions. So please bear with me. So now my first thing is to, okay, this is still an example of those functions that I discussed with you. I actually touched on that already to tell you the shape of different type of function. So linear functions, it's usually, this is the slope intercept form of your linear functions that we have here. Right? Quadratic functions, the expression for them, you see there are 5 possible expressions for quadratic function, but technically, if you want to be rigorous, I'll say it's only 3 of them. The 3 that I circled here, okay? So the ax squared plus bx plus c, you can have the number 4 here. It's the one that allows you to get the turning point easily. And number 5 allow you to find the intercepts easily, the x-intercept easily. So that's how you write quadratic functions. So every time you see expressions like the one I circled there, grade 12, you know that you're dealing with quadratic function. Hyperbolic functions, you have these different expressions. Let me bring in some colors. So a hyperbolic function, I'm circling that in green. So this is how the graph will look like, as we discussed. And exponential functions, that's how it looks, and that's how the graph will look like. So at least you know, just to spend a little bit of time, at least here, you know exactly how the type of functions that you'll be dealing in your metric paper. When you're dealing with functions, sometimes some of them are given to you in the formula sheet in terms of some formulas, but with more practice, you'll be able to solve any questions that is related to those type of functions. So now let's move to quadratic. That's my first example of functions where I want to spend more time. So as I indicated to you, you have different expression for quadratic. You can have these expressions here. You can have this one. The second expression is like the first one, where b is equals to 0. Then you get the first one. And this other expression here, the third one, is the one that allows you to find the turning points. So usually, when your a is positive, you have the happy. So this is your happy functions here. Right? If you think about it small, a positive, it's concave up. When a is negative, it's concave down, and your graph will have a maximum. So when a is positive, you know that you'll have a minimum. When a is negative, you'll have a maximum. Okay? So that's happy face, sad face, depending on concavity of the functions. So those are a few generality on hyperbola. Now let's look at an example here. So here, this is my example. I start with f of x is x squared minus 6x minus 16. Okay, we want to find the intercept. To find the intercept, just like for any other functions, intercept means the point of contact with the x-axis and the y-axis. Okay, so when you want to find your x-intercept, you set f of x or y equals to 0. Like in this case, I set it's a quadratic. I factorize the quadratic like that. And when I finish factorizing, I hope you guys, you're grade 12, okay? Since grade 8, you learn how to factorize this quadratic, right? So usually you look at this number, for those of you that are struggling, this number 16, you look at the factors of 16, and you look at the one that can combine to give you minus 6. So like 16 here, we look at 8 and 2. And it's good for us to have minus 8 and 2, and we have that factorization. And then in this case, our intercept x is equals to minus 2 and x is equals to 3. Okay, so to find your x-intercept, you can do that. This is another example where there is no x-intercept, because when you look at the expression, it's a quadratic. We know the quadratic formula. And we see here square root of a negative, so it's not real. It indicates to us that this function has no x-intercept. It doesn't cross the x-axis. So when you're given the graph, you can easily see that this graph is not passing on the x-axis, so no x-intercept. But when you're given the expression, you can demonstrate or prove rigorously, as we did here, finding that the discriminant is negative, no real root. So the graph of that function will not pass on the x-axis, okay? So remember, when you're studying any functions, you're always interested in the intercept, x-intercept, y-intercept, and then after that, you'll be interested in what we call asymptotes. But for parabola, we have no asymptotes, okay? So this one, it's when the intercept, here, this is another example here, x squared minus 2x plus 1. But we know that this is x minus 1. If you remember your identities that you know, this is x minus 1 squared is equal to 0. So it's a colliding x-intercept. So it's only a single x-intercept. Because it's a quadratic, you can have at most 2 x-intercepts, okay? A quadratic function will have at most 2 real roots. It can be without roots when the discriminant is negative. It can be with 2 roots when the discriminant is positive, or a single root when the discriminant is equal to 0. The discriminant is the delta that we have there, grade 12. I hope you can still listen. I hope if you have questions, I'm not keeping track on the chat. So if you have questions, write it on the chat. I will look at that in the last 10 minutes. Like at 11:50, I will stop presenting and look at the questions you have in the chat and be able to answer to you. But please follow me carefully. Because I'm trying to be as clear and explicit as possible. So I explained to you the x-intercept when you're dealing with quadratic functions. So there is 3 possibilities: no intercept, as we saw in this example here, no x-intercept. This one has 2 x-intercepts, and this one has only 1 x-intercept. Now, to find your y-intercept, you set in general x is equals to 0. So in the expression, in this case, my example is g of x, 3x squared minus 4x plus 1. So if I'm interested in the y-intercept, I just let x to be 0. Grade 12. This is very important. So you just take x to be 0 and you substitute in your expression, as I did here for g, 3 times 0 squared minus 4 times 0 plus 6, and I get y is equals to 6. So my y-intercept here is the point of coordinate 0, 6. I will show you that in the examples. This is another examples below here, x squared minus 2x minus 3. To work out my y-intercept, I just substitute 0. And when I do that, I find the value y is equals to -3. So my y-intercept is there, my y-intercept is there. So grade 12, we are good. For parabola, you can find your intercept easily by setting x is equals to 0, y is equals to 0. But in general, this is your formula. So remember, I told you 2 important formula for your, these are your turning points now. Sorry, I'm moving ahead because parabolas always have turning points. And you ask yourself, what is the x coordinates of the turning points that correspond to your axis of symmetry? Because if you put on your graph, like if you're drawing a parabola and I told you your turning point is located here, let's call that x bar, then you work out the y value and that will be when your parabola will turn. Okay, so that point there, it's your turning point. So depending on the expression, if you use this expression, grade 12, I told you at the start that this is your general form for the parabola. With this general form, your turning points correspond to this. Grade 12, you already know the advanced technique how to prove this using differentiations, but I won't spend time on that because I'm not teaching you calculus. You can use differentiation, calculus to demonstrate to yourself that this is absolutely the x value of the turning points, but I prefer you to take it for now as a formula. If you start from this expression, your turning points or the coordinates of your axis of symmetry, the point where you have your symmetry will be x is equals to minus p. So if you start from this form, it tells you exactly what the turning point is. It's minus p just by setting this square expression to be 0. Okay, grade 12, I hope you're still fine. I illustrate that on an example. This is x squared minus 4x minus 5. If I want to find my x coordinates of the turning points, I do x is equals to minus b over 2a. My b here is -4. 2a, a is 1 minus 4 over 2 times 1. I'm here, grade 12, and then I end up with -2. Okay, now if I have these other g expressions here at the bottom, so if I have this other expression, which is given like this. If I have this other expression, then it's easy for us to see that the coordinates of the turning points of the axis of symmetry is just x is equals to -5. Grade 12, I hope you're still comfortable. Now, domain and range of a quadratic functions. In the previous class for the grade 11, we were talking about domain and range, okay? And I learned today, or many of you that joined the grade 11 class, I remember we advise you, especially the grade 12, if you're struggling, that you should attend from grade 10 to 12, because most of the material that you ask at matric, it doesn't just come from what you're covering in grade 12, it's from grade 10, 11, and 12. So from grade 10, you were learning about this domain and range of a function. For a quadratic function, the domain is the full set of real number. As you can see, there is no restriction. What sometimes allow you to discriminate about your domain not to be a real number, it's usually the vertical asymptotes. So you can see that the quadratic has no vertical asymptote. So if you pick any value of x on the real line, you can work out it will touch the graph of the function f. So the domain of your quadratic function, it's always the whole set of real number that you can write like that or write like that, okay? Now, what is the range of your quadratic functions? It's very, very important depending on whether your function has a minimum, like the case here, or it has a maximum, like it's in the case on the right there, okay? So either your function have a minimum or a maximum, like in that case. When your function has a minimum, then your domain, like you see here, if you go below the point -4, y is equals to -4, the graph of the function doesn't touch anything below that graph that I'm drawing there, grade 12. So therefore, your range will be anything that is bigger than -4. So your range here is y greater than -4, and you can also write it in set notation like that, okay? So in general, depending on the form of your graph, your range can be given in general like that. When you are now in this case where you have a maximum, you'll see as well that this from there y is equals to 4. If you have y greater than 4, the value of the function never reaches there. So here your range will then be from -infinity to 4. So y less than 4 or y from -infinity to 4. So the range of your quadratic functions, when you have the graph in front of you, it's easy. But even if you have the expression, you can also work it out easily from the coordinates of that turning points. That's why I spent a little bit of time with you, grade 12. Where was that? Here, discussing the turning points. Because this x that I told you, when you get that x, you put it and get the y value, and that's what will allow you to specify your range easily. Okay. So this is a summary of the turning points that I already discussed a little bit with you. Depending on the expression that you have, and as I indicated, grade 12, this is the way you proceed. You work out the derivative and set it to 0. It will give you the coordinates of the turning points. I know normally in grade 10, you'll focus more on these formulas. Grade 11, you'll include that. And in grade 12, you now use calculus to find your turning points. But this is clear, I hope. So that's the theory. That's what I think you need to know about your quadratic domain, range, turning points. Okay, because most of the questions revolve usually around those 4 concepts. So let's move on to look at some example. Before I do that, let's quickly tell you how you proceed to sketch the graph of a quadratic function. To sketch the graph of a quadratic function, you determine, remember I told you when a is positive, it's concave up. When a is negative, it's concave down. That's the first thing you need to look at. So when I write an expression for a quadratic function, like this one that we'll study later, just by looking at the a here, which is 2, I can tell you that it has to be concave up, even without drawing anything. So that's the first thing you do. Now, if you want to go more deeper, you look at your x-intercept. X-intercept by letting y is equal to 0 or f of x is equal to 0. You find your y-intercept by checking x is equal to 0 and find the y value. You find the turning points, and when you find the turning point, you put maybe a couple of more points, and then you connect those points together to sketch your graph. So it's just like all other graphs, okay? But in this case, those are your steps to sketch your graph. So let's look at our first example, grade 12. We are ready for it. We can go now, and please look at my solutions here, where you have the marking guides, how you get your partial points, because you need to present your result according to CAPS, according to our system here in South Africa. And that's why you have this column here that will tell you how the marks are allocated depending on what you write in your answer sheet. But we will not focus too much about how the marks are allocated. We'll focus on how we get this correct. So let's look at our first example then. 2x squared minus 2. Determine the coordinates of the y-intercept of the graph of f. Y-intercept, you set x to be 0. That's something I've taught you already. So we just take x to be 0, we substitute in the expression, and we found y to be 2, and we write the coordinates of the point, which is 0, 2. So it's important to write the answer. I just circled the answer to you, grade 12. So when you put x to be 0, at the end you find y to be 2. It's important that you write that my y-intercept is the point of coordinate 0, 2 that I have circled there. Let me actually circle that with another color so that it's clear. So this is my answer here, 0, 2. The second question, grade 12, 1.2. Determine the coordinate of the x-coordinate of x. The coordinates of the x-intercept, x-intercept of x. The first question was about the y-intercept. To find the x-intercept, you set y is equal to 0. This is a quadratic. I want to make it 0. then I need to factorize it. I see that I can simplify by 2. That's why 2x squared minus 1 now equals to 0 means that 0 is equal to x squared minus 1. This is an identity because 1 here is 1 squared, so it will be 0 equals to x minus 1 into x plus 1. I'm here grade 12, and here then I can just set each of the term, x is equals to 1 or x is equals to minus 1. And therefore my y-intercept, this is my answer, the point of coordinate 1, 0, and the point of coordinate minus 1, 0. Next question, 1.3, grade 12, determine the coordinates of the turning points of f. To find the turning points, we can look at this. Remember, this looks like the expression that we have. So 2 into x minus 0 squared minus 2. Okay, so if you remember the expression I show you, it's easy for you to see then what the turning point is because it's minus p, but minus 0 is 0. Okay, so that's your p. So the turning points here correspond to minus 2, 0. I hope this, yeah. I think this is not written properly. The correct writing here is 0 minus 2. Okay, grade 12, please pay attention to that. I should have been writing that myself, but you can see here that the x coordinate of the turning point is 0 and the y coordinate is negative 2, right? Because you have 0 here. So your coordinates, as I indicated to you here, turning point is x is equal to minus p. So this minus p for us corresponds to 0. And the y coordinate, you just substitute the 0 back and you get negative 2. So the answer here is 0, negative 2. But you'll notice that that's what I put there. So the turning point here, the coordinate is 0, minus 2, not minus 2, 0 there, grade 12. Sketch the graph of f clearly showing the intercept with the axis and turning points. So to sketch the graph, as we indicated, the steps, we already saw that it's concave up. So concave up, we found the y-intercept to be 0, 2. Y-intercept. Y-intercept is 0, minus 2, colleague. I think I didn't write my answer correctly, but this is y is equals to negative 2. Because if you set x to be 0 here, it's negative 2. So your answer for 1.1 is actually 0, negative 2, not 0, 2. So that's what is represented here for your y-intercept. Your x-intercepts are correctly represented here at minus 1 and 1 on the x-axis. So with those 3 points, and this is the turning points as well, the turning point is 0, negative 2. So with those 3 points, you can easily sketch your graph. Okay, so this is the graph here. Grade 12, and I hope it's clear. So you put your y-intercept 0, minus 2, x-intercept minus 1, 0, 1, 0, and your turning point is the same as the y-intercept 0, minus 2, and you connect those 2 points. Okay, those 3 points and carry on. You could work out f of 2. If you work out with x is equals to 2, you do get 2 times 4, 8, 8 minus 2, 6. So 2 here will correspond to 6, and minus 2 will correspond to something else. Minus 2 will also correspond to 6, and then you have the graph. Okay, so that's a sketch of the graph, graph 12. I hope it's clear. What is the range of f? The range of f here, remember, the range of f is anything that is greater than negative 2. Okay, so y greater than negative 2. That's how you can write your range as well, but you can also write it in set notations like this. Okay. Determine the point A if 2A is a point on the graph of f of x. Determine A if 2A is a point on the graph of f. I hope I didn't write that down, but I can do that. So if you take 2A, so it means when y is equals to a is equals to 2 into 2 squared minus 2. Okay, because remember when I say 2a is a point of the graph, it means that f of 2 equals to a. Okay, so when I do f of 2 is equals to a, that's a. F of 2, 2 into 2 squared minus 1. So this is 2 times 4 minus 2. So your answer is 6. A is equals to 6. Okay, grade 12. I hope that examples have helped you to understand more about how to do your parabolic functions. So let's go to the second example. Now where I have the 3 terms. So this is my function f, x squared minus 4x minus 12. Just like in the previous example, because a here it's 1 positive, we know that the shape of this graph, even before looking at the right-hand side, it's concave up, okay? So the questions are just like in the previous questions. Find the coordinates of the y-intercept. The y-intercept, you just have to put x to be 0. So here, this one, you do x is equals to 0. You substitute x is equals to 0. You'll find y to be negative 12 because it's 0 squared minus 4 times 0 minus 12. So my y-intercept is 0, negative 12. Grade 12, it's important to put a few details. So when I say coordinates of the y-intercept, you say x is equals to 0. You take that 0, you substitute in the function, and you get your y to be negative 12. So that's a working that we're supposed to appear there in 2.1. Let's move to 2.2. 2.2, determine the x-intercept of f. So you set the expression there equals to 0, you factorize, and then you see that x has to be equals to 6, or x is negative 2. Okay, and with this, it's important to write your coordinates, negative 2, 0, and 6, 0. So those are your coordinates of the intercept. Grade 12, negative 2, 0, and 6, 0. The second question, find the coordinates of the turning points. We just use the formula minus b over 2a, substitute b and substitute a, and end up with x is equals to negative 3. That's the x coordinates of my turning points. I take that negative 3 and substitute in the expression of f of x. And we get y is equals to 3. And our turning point is given there by minus 3, 9. The next step is to sketch the graph of the function f. Sketching the graph is like putting together, grade 12, all the information I did from question 2.1 to 2.3 in a graph. So I draw my x-axis, my y-axis, draw them, and then put the coordinates of, I start with my y-intercept, 0, negative 12. That's the point there. And then I go to my x coordinates, negative 2, 0, and 6, 0. And when I do that, I go to my turning points, negative 3, 9. X is negative 3. I hope my turning points, my turning points look strange to me, grade 12. From the graph I have here, negative 2, 9, that doesn't look, so minus 6, minus b, yeah, this is completely off. Minus b is, it's minus b, this is negative 2, sorry, negative 4, grade 12, over 2a, 2 times 1, so it turns out to be 2, okay? Colleagues, so this is not the correct expressions here. So x is equals to 2, and then I work out the y value for 2, and I end up with something around negative 16. So this is actually 2, negative 16. Grade 12, you can check this a little bit. So all looks to be fine. We have to do the correct replacement. I don't know where I came out with 6 there, but the b here is negative 4, grade 12. B is negative 4, a is equals to 1, and c is equals to negative 12. So minus b over 2a, it will be minus 4 over 2. The answer is 2, and you substitute 2 there and get 16. So this is the correct coordinates of my turning points here that correspond to 2 in the x-axis and negative 16 in the y-axis. Okay. So when I get those 3 points, I place some few other points, and then I connect them, and I am done. Okay. What is the range? The range here, just like in the previous example, will be negative 16 and plus infinity. So because this is the minimum, remember every time you have a minimum, your range is from the y value of your minimum to plus infinity. Okay, grade 12. If you have a maximum, it will be from minus infinity to the y value of your turning point. Okay. So grade 12, with that, I think you will understand very much quadratic functions. This is the last examples that have to do with the other expression I indicated to you. X plus 4 all square minus 1. This is my next example. Write down the coordinates of the turning points. The turning points here will correspond to minus PQ in the formula that we have. P here being 4, minus P is negative 4, and the Q here negative 1. So the turning point, you just read it from the graph. So that's sorted. Write down the coordinates of the turning point. That's done. 3.1. 3.2, determine the x-intercept of G. The x-intercept, you set G is equals to 0. So G of x, 0 is equals to x plus 4 square minus 1. You send 1 to the other side and becomes 1 is equals to x plus 4 square. It means x plus 4 is plus or minus 1. And then you break it down and you find x to be negative 3 and x to be negative 5. So our intercept corresponds to x is equals to negative 3 and negative 5. As you can see, I put it on the graph. The turning points minus 4 minus 1. And then you place a few more points and then you get your graph. Okay, and from this you can get your range. Your range, as I indicated, because it's concave down as well, concave up as well, your range corresponds to the y value that goes there. That means anything that is greater than negative 1. Okay, so that's our y, the range. Okay, and grade 12, I hope this is clear to you. I've gone through this example looking at the 3 different forms that I show you, and this is how you could solve these problems and take all these marks. Okay, remember on the right hand side you see what you actually need to write down so that you can achieve full marks on the questions I'm covering with you. I think it will be important for me to move to hyperbolic because the time is not looking very good. I will share the slides with you and leave you read those by yourself. I need to touch a little bit about hyperbolic before we go because my plan with you was to talk about parabolic and hyperbolic. So the expression for hyperbolic, as I indicated to you, it's something like that. When A is positive, then your graph will be in the first and the third quadrant. And when A is negative, your graph will be in the second and the fourth quadrant, grade 12. So A positive corresponds to that, A negative corresponds to that. Just by looking at the expression, this is the one where we spend more attention, you can have an idea of how your graph will look like. Now for hyperbolic functions, we do have asymptotes because asymptotes correspond to regions where, for example, x asymptotes is correspond to when your function is not defined. Okay, so yeah, so the range, the domain of these functions, the domain of your function is always x not equals to p, negative p. This is the domain here. Okay, the domain of any hyperbolic function corresponds to the real number and you exclude the one for which that denominator is equals to 0. And that denominator is equals to 0 when x is negative p. So your domain of your hyperbolic function is x, all real number except x is equals to negative p. Your range also will correspond to all real number except q. Okay, because Q is your horizontal asymptote. Okay, so let me leave those effects and discuss the asymptotes with you. Or so usually your asymptotes, I think I have an expression for that. Your asymptotes correspond to minus PQ. X is equals to minus P is your horizontal asymptote in any case, and Y is equals to Q is your this is your vertical asymptote. X is equals to minus P, and the horizontal one is Y is equals to Q. Okay, grade 12. So now let's quickly look at an example. Okay, the intercept is the same idea. Let's look at the domain. I've discussed the domain. X x is not equal to negative p. This is my example to illustrate the domain to you. And the range, as I indicated there, it's always like that, okay? And sometimes also you discuss about this axis of symmetry, and the axis of symmetry correspond to these graphs given by this expression here, grade 12, and there as well. So I will share these slides with you, but let's look at an examples because I'm nearing the end. I told you the last 10 minutes, it's supposed to be for question and answer. So I'll just do one example with you, and then I'll go to the chat and see if there's any questions before I proceed. Sketching this hyperbola. So if you want to sketch a hyperbola like I did with parabola, 4 things you need to check. Determine the shape. So you look at the A. When A is positive, you know that it's got to be in the first quadrant and in the fourth quadrant, in the third quadrant. I think I've explained that to you here. So when A is positive, it's first and third quadrant. When A is negative, it's second and fourth quadrant. Write down the equations of the asymptotes. X is equals to minus P and Y is equals to Q. Determine the X and Y intercept, just like we did for parabola. And when you have that, you can then stretch your graph. So let's look at this example, grade 12. I'm sorry, I'm rushing a little bit, but I hope you can still follow me. So this one, write down the equations of the asymptotes. We can look at the expression here and see that my P is equals to 0 and my Q is negative 3. So my asymptotes will correspond to X is equals to 0, Y is equals to negative 3. So that's your asymptotes. Very easy. So you need to identify the expression you have with the generic expression for the hyperbola that I show you. Write down the domain and the range of the functions. So the domain is X except X is equals to 0. So when you have your asymptotes, it gives you an indication of your domain and the range, because the X value there, it's the one that you have to take out from your domain. So the domain is all real number except X is equals to 0. And your range is all real number except Y is equals to negative 3. Calculate the x-intercept of the graph of f. X-intercept, you set f of x equals to 0. Grade 12, this is where we are. We do some algebra, sending the negative 3 to the other sides, and eventually we solve and get x is equals to 2/3. So that's our answer. That corresponds to our x-intercept of the graph of f. In general, grade 12, you want to say that your x-intercept is 2/3 0. Okay? Draw a neat sketch of the graph showing all intercepts with the axis and asymptotes. So here I start with my XY axis, and so this is XY axis, and then you draw your asymptotes. So the asymptote is X is equals to 0, which corresponds to the Y axis, right? So this is X is equals to 0, and then you do Y is equals to negative 3. That's my other asymptotes. A is positive, so the graph is in the first and the third quadrant, and that's my graph. I can put it like that, and including also my x-intercept, which is the 2/3. That is the point there, grade 12. Okay, so really not too difficult to sketch this graph when you have already worked out the important information. But remember, this is your map when you're doing the sketching. Shape given by A, equation of the asymptotes, negative PQ, X and Y intercept, just like we did for parabola, and then you can then sketch easily. Determine the equations of the axis of symmetry that has a positive gradient. Remember the equations of axis of symmetry, grade 12, I think I showed that to you. It's X plus P plus Q like that, or minus X plus P minus Q. So we're looking at this region here and this region. The one that has a positive axis, positive gradient, negative gradient, we always use such a formula. So in this case, I am here. So axis of symmetry that has a positive gradient. So it should be Y is equals to X plus 0 plus Q, but our Q is negative 3. So our answer is just Y is equals to X minus 3. Okay. Grade 12, I have a lot of other examples that I plan to cover with you, but no time to discuss that. So let me see what questions you have for me. Is there any question on the chat, admin? Okay. It's very general. So how does those shape of the small face change in relation to the change in the coefficients of x squared? I did answer that this is the parabola one. So when the coefficients of x squared is positive, it's a happy face. When the coefficients is negative, it's a unhappy face. So positive means you'll have a minimum, negative means you'll have a maximum. Okay, so that's how you do it, right? What is the difference in how open the small face is when there is 3x squared compared to 7x squared? No big difference. This is all about scaling, okay? Right? When you do your sketch, if you want to be accurate on your sketch, it will tell you how it opens and how it doesn't open. But the key thing is positive, negative, happy or not happy. When you do your sketch, you just need to put more points in the domain, take more points and put them in the graph in your XY plane, and you connect those points. It will tell you how open and how close, how open your happy face is, okay? That's usually not something you are very much interested in, because when you have your turning points, your intercept, if you want to draw your graph more accurately, put more points in your x-axis, work out the corresponding y value and connect those points so that you can have a more accurate shape of your graph, okay? You want me to go through slide 19 again? Where is my slide 19? Did I even count them? Yeah, 19. This is slide 19. Yeah, slide 19. It's about, yeah, that's what I have. Huh? This is 2019. Slide 19, it's about the intercept for a parabola, for a hyperbola, okay? X-intercept, Y-intercept, and the domain, the range, okay, with some examples to illustrate, and also the asymptotes, vertical asymptote, horizontal asymptote, and the axis of symmetry, the one with a positive slope and the one with a negative slope. They are really not too difficult. Grid 12, as you can see, it's something that you can actually touch on, okay? But maybe because you asked that question, it indicates to me that maybe you haven't completely understood the concept, and because I have a little bit more time, I can take you to my second example. I don't know if I want to do that one or the one that is more articulated. I want to take you through this example where I start from the graph, okay? Let me take you through this. It will be the last thing I cover with you, grade 12. I know that after this, grade 12, don't go away. We have a lucky draw after this lecture where you can win some awesome prizes. So don't go away, okay? I'm still with you for 6 minutes. I'll try to keep it on the 6. But let me take you through these examples that you see in grade 12, where I start now with the graph and I have some questions. Because all the examples I did with you, I had expressions and then eventually sketch the graph. So the diagram below represents the graph of these functions here. This looks like a hyperbola for us, okay? P of coordinates 4, -3 is a point on F, and equations of asymptote is y is equals to 2. Determine the equation of H. Grade 12, this is not a very difficult question. Because we were given this expression and we told that the asymptote is y is equals to 2, we know that our general expression for the vertical, this is the horizontal asymptote. The horizontal asymptote, y is equals to 2, tells us that q needs to be equals to 2, right? So q is equals to 2. That's what you see here, that I already put 2 there. Q is equals to 2. Now when I substitute, now I have y is equals to ax plus 2. So I put the fact that the horizontal asymptote is y is equals to 2 on the expression. Now I am left to find a. To find a, I remember that the point of coordinate 4, 3 belongs to the graph. So I put when y is equals to 3, x has to be equals to 4. That's what I substitute there, grade 12. And then I just do some algebra. So that means 2 goes to the other side, 3 minus 2, 1. A over 4 is equals to 1, cross multiply, A is equals to 4. So now I'm sorted. The equations of my graph is h of x is equals to 4 over x plus 2. Okay, so that's a general expression. Normally you needed to write that down completely. This is your final answer. H of x is 4 over x plus 2. Calculate the coordinates of the y, the x-intercept of h. X-intercept means that I have to set y is equals to 0, grade 12. I do that. 2 goes to the other side, it becomes -2. And then I do some algebra and end up with x is equal to -2. So my y-intercept, I was looking for the x-intercept. My x-intercept coordinate is -2, 0. So that's your answer, -2, 0. Determine from the graph the value of x for which h of x is negative. And this is very important, grade 12. H of x negative means that I have to find the x values that correspond for the graph of x being below the x-axis, okay? So you want the value of h for which h of x is negative. So this is my x-axis. The graph of h that is below that graph will correspond to this portion of the graph here. So what are the x value that correspond to this graph? This value here, it's the x-intercept. We found it to be -2, -2, 0, right? Are we okay, grade 12? So that portion, and this is the asymptote that corresponds to x is equal to 0, because our vertical asymptote is x is equal to 0. So the part where the graph is below, it's just that part, and you take the x value, -2, 0, and you see that it will never touch 0, because 0 is the asymptote. That's why we have open here and close there, because the value -2 is reached. So that's 1.3.1. Also, they say determine the graph from the graph the value of x for which h is increasing. Is h increasing? The function h is decreasing all the time, isn't it? So h is not increasing anywhere. So therefore, we can conclude that there is no answer for that. It's an empty set. Calculate the range of p, where p of x is minus h of x plus 1. Minus h of x plus 1. You substitute. This is minus h of x plus 1. I play around with the expression and I arrive at this. This is the expression of p. Okay. And then the range of this, the asymptote, the y asymptote will correspond to -3, right? Are we okay? I mean, negative. So here, the y asymptote here is y is equal to -1. So grade 12, remember that to get your range, you always say everything on the y-axis except the y asymptote. Yeah, so this is our horizontal asymptote. Y is equal to -1. So our range for p will be every real number except y is equal to -1. Grade 12, I hope that example helped you to understand further all the concepts related to all these functions that we have looked at today. We have looked at parabolic equations, parabolic functions, and hyperbolic functions. How do we find the domain? How do we find the range? How do we find the asymptotes for the hyperbolic ones? And how do we find the turning points for the parabolic ones? And how do we sketch the graph? I hope that I have supported you in understanding better those concepts and all those type of questions that you'll face at matric related to this topic of on functions. I haven't touched on exponential functions. I haven't touched much on linear functions, but I've shared with you a resource that will allow you to understand that better. Grade 12, I think I will stop sharing and I am done. There is no further questions that I can see, moderators. And I think I would call it a day. I hope it was interesting for you, grade 12. I hope you are well supported for matric and that these concepts make sense to you, but you're welcome to contact us if you have further questions. But please make use of that study guides that I share with you from where I draw the material that I use for our class today. That study guide also includes some maths of finance, and it includes all the other type of functions, the linear and the exponential. Thank you so much. I think I'll call it a day. Chair of the sessions or the moderator.
Thank you, Doc, for clearly breaking down the function with us. We really enjoyed the session.
Okay.
As we move to our last but not least session of the day, of which I highlighted earlier, the career guardians, of which will be held by Nondumiso Khumalo. Nondumiso Khumalo, I think you should be here.
Sbahle, she's just joining, so I don't know, learners, do you have any final questions for Dr. Medard while we wait for our speaker to join and settle? Okay, Sbahle, she's here, so you can introduce her.
Oh, okay, Doc, thank you. We'll be having Nondumiso Khumalo from the space weather forecast at SANSA. So if she's already here, she can take over. Thank you.
Good day, everyone. Good day, everyone. So thank you for having me today. My name is Nondumiso, I think as it was mentioned. I currently am working as a space weather forecaster at the South African National Space Agency. So today I'll be taking you through a short presentation of mine where I speak about what is it actually to become a space weather forecaster. As I know with TTN, we've been learning a lot about mathematics, so it would be really interesting, I think, for everyone to know. So now that you are doing mathematics, where can you actually land up in terms of your career choices? So I'll be here to help with that. So if you have any questions, please feel free to leave any on the chat, and I'll be more than willing to respond to you. So I'll just be opening up my presentation. Okay. Okay, please confirm if everyone can see my screen.
Yes, you can see your screen.
Okay, thank you so much.
Thank you.
So good day, everyone. So as I mentioned, my name is Nondumiso, and I am a space weather forecaster here at the South African National Space Agency. And I'll be just giving you an overview of what I do here. So I'm not sure if any of you have heard of the term space weather. So space weather basically refers to the conditions in space, and these are caused by the sun. And these can affect the satellite and technology that we use on Earth. So my job as a space weather forecaster is to monitor the conditions that are in space that are caused by the sun, that you can see here on your, well, on my left, I think your left as well. You can see the sun, and what the sun does is that it emits these very powerful explosions of plasma, which we call coronal mass ejections. And when these energetic particles explode from the sun, as you can see here, they get directed towards Earth, which is the small ball you see here, within our magnetic field. And then it interacts with our magnetic field, disturbing it and causing what we call geomagnetic storms. Right, and the reason why we pay attention to such phenomena is because it can affect our technology that we use here on Earth. I'll explain more on that in the next slide. But since we need to know what the sun is doing, it's also important for us to look at the sun and observe it in order for us to predict when these events can happen, right? So at the bottom here, you can see these 4 images. These are all images of the sun. You can see them in different colors because we use a satellite which is in space that looks at the sun, right? And then we get to see what's happening on there. So these are all images of the sun, and they are taken through different filters so that we are able to see the different features that are on the sun, so that we can kind of predict what's going to happen, right? So these images I took this morning, so they are near real time. So this is currently how the sun is looking today. You can see a lot of different features. Here, the black part is called a coronal hole. And the other images show us the regions where we get active regions. So we call these bright spots active regions, the regions where we have more activity happening on the sun. And the last one shows us the sunspots. So these are regions on the sun that are cooler than their surroundings. We call these sunspots. They are also an origin for space weather activity, or these coronal mass ejections. So coronal mass ejections also emerge from these spots here. So some of the technology that the space weather does affects, it's satellites. So you can imagine these very powerful bursts of plasma erupting from the sun and and then they travel from the sun to the earth. We all know that we have satellites orbiting Earth on a 24/7 basis, for example, Starlink, right? So now when you get these very energetic particles coming towards Earth, you can only imagine what they can do should they hit against these satellites. And we know that nowadays we rely so heavily on satellite communication. For example, your banking app, it uses satellite communication for you to transfer money. So now imagine there's a space weather event and it affects satellites. It can cause disaster in terms of like the technology that we use here on Earth, like banking applications. Another thing that space weather can affect is human space exploration. We know that we have astronauts in space that sometimes leave the spaceship or the ISS, the spacecraft rather, to go outside or to do like movements outside of the spacecraft. So they are exposed to radiation. So knowing what activity is there in space, in terms of space weather, is important for them in order to protect them from radiation exposure. Another thing that space weather can affect is radio communication, as we also get phenomena known as solar flares that happen on the sun that affect radio communication. And we know that radio communication is also used in aviation. So if we have space weather activity, it can also disrupt high frequency radio communication that is used by the aviation sector. Well, as I think most of you who may be physics students, you'd also know that when there's a change in a magnetic field is produced, rate of change of a magnetic field also produces an electric current. So because when a space weather event happens, it disrupts our Earth's magnetic field, causing it to change. And in turn, we can get the power grid having a surge of electricity that is produced from space weather, which can damage our electric lines, our long distance electric lines, because of these enhancements. So it can also cause a disruption on our electric power. So before I move on, just to give you a background of my academic journey. So I was a UKZN student as well. I did my BSc in Applied Mathematics and Physics. I completed it in, I started it in 2015. And then in 2018, I did an honors program called the National Astrophysics and Space Science Program, which is offered at the UKZN, as well as Northwest University, as well as UCT. But I did mine in UKZN. Excuse me. So I therefore went forward to do my MSc, my master's degree, also in applied mathematics, focusing more on astrophysics. So just to give you an idea of what I do here at SANSA. So these are just some of my colleagues that we have here. So this is our group. We have here in the middle, Dr. Mpochi Sapungo, which is our space weather manager. And I also have my colleagues here. We are all space weather forecasters. I think here I have 4 of our forecasters missing because we recently employed 4 more. So now we have a group of 12 forecasters which are operating the Space Weather Center here that we work in. Okay, and one of these is also Salma Khan, which was also a former UKZN student. So my job here deals with monitoring space weather conditions, so observing whatever is happening in space and seeing how it can affect us here on Earth. So once I see how the sun is behaving, and if there's a coronal mass ejection being released from the sun and posing a risk rather at Earth, I then compile what we call a space weather bulletin, which you see here at the bottom here. This can be found on our website. We issue these on a daily. So these just give you just a summary of activity that has been happening over the past 24 hours. And we also forecast what to expect in the next 24 hours in terms of space weather activity. So for you to just get this information, you can just type SANSA space weather, and it should take you to this page where you can explore the information that we have. So the other thing is that we issue warnings and alerts to our clients should we have any significant events that are taking place on the sun, so that we can warn them. So we warn them so that they can take caution when using their technological systems. We also here at SANSA very much believe in science outreach. So what we do here at our sites, we do what we call a public tour. So every Wednesdays at 11 a.m., SANSA hosts a public tour where the public gets to come and explore the whole facility, where we also give an explanation, or a tour of our space weather facility. So this is just how the building looks. So this building was actually launched in 2022 as a 24/7 space weather center, because before then we were only operating on a Monday to Friday basis. But on 22, I think that November 2022 rather, this building was launched where we are currently operating our space weather services. And this is just the look inside this space weather center where we operate on a 24/7 basis. So just to expand on some of the other programs that we have here at SANSA, so I'm situated in Harmonis in the Western Cape, where we look mainly at space science. This is where we do space weather. But there are also other programs at Center. So we have one program which is called Earth Observations. This is situated in Pretoria in Gauteng, where they use a satellite imagery to look at Earth, right? So they get to survey the Earth and therefore give some advice in terms of for example, agriculture. So they can take images of land and give advisories to people who might need it, maybe to produce crops, or maybe also find out about damages. Because this is the second image is was taken from Port River in the Western Cape when we experienced flooding. I think it was in 2023. So you can just see the satellite image showing you a bridge that was there before and after the flood. So that is what our Earth observation focuses on here at SANSA. And then, of course, I explained here in SANSA, space science, we look at space weather. It's one of the things we look at. We look at space science research. We also have an applied science and technology department where it deals with magnetic observations. We also we deploy some of our engineers to go to Antarctica, which is at the South Pole, where they get to monitor and maintain the instruments that we have there, like this radar that we have in Antarctica. We also have a space engineering department or program, which deals at calibrating instruments that can go onto spacecraft or satellites. That's currently underway in Grabo here in the Western Cape. Last but not least is our space operations program, which is situated in a very remote, isolated place called Hartbeespoort in Gauteng. So there we have a span of antennas which are used for satellite tracking. So this facility, as you can see, it has a lot of antennas all around the site, and these are used to look at the satellites as they orbit around Earth. So when they pass over South Africa, we are able to give the information to maybe the people who own those satellites overseas, or international owners of those satellites. So just to give you an idea as well of what careers you can expect at SANSA, since this TTN is a mathematics program, it's good to also emphasize that most of these jobs here at SANSA or careers are mostly based on mathematics. So it's very encouraged for you to pursue mathematics, because it can open for you a door of opportunities. So okay, so we have a space weather forecaster, which is a job I'm currently doing. You can also become an ICT specialist, of course, because we use ICT here. You can become a researcher, okay? So we have Earth observation researchers. We also have here space weather researchers on site here at SANSA, space science. You can also become a satellite operations technician. So you can be sitting in Hartbeespoort, controlling those antennas as they are tracking the satellite movement or transitions. You can also become a science engagement educator. So I did mention that SANSA has a very strong belief in science outreach. So we have a science engagement unit, which is dedicated to going out to schools and teaching about science, and especially what we do here at SANSA. So if you like to be an educator, it's also a good opportunity for you to be involved in such a career. We also have programmers. Of course, we know we need a lot of computer programming in all of our research. So we also have some careers in that as well. You can become a remote sensing scientist working in Earth observations, where you can be looking at these satellite images of the Earth and giving conclusions of what is happening in terms of maybe crops, human settlement, and agriculture, etc. And even as I mentioned before, natural disaster as well. You can give information or analysis or analyze that if you become a remote sensing scientist. You can also take the route of engineering. So here at SANSA, we have a span of engineers that we have. You can become an electrical engineer, an electronics engineer, which are particularly deployed to Antarctica. So here at SANSA, we, on every year, we deploy 2 Antarctica engineers, electronics engineers, to go and maintain the radar that we have there in Antarctica. So this is just an image of 2 of those engineers which live in the snow, basically. So they get to go there for 15 months. They are first trained here at SANSA, space science, and then they get deployed to Antarctica for a period of 15 months, and they can't come back. They can't come back. They can only come back after the 15 months. So you are just there in the snow throughout the whole year. Right, so these are just a few that we have here at SANSA, but there are some more, so just if you are really interested in having a career at SANSA, you can also do some research on some more careers which we have here, and I'm sure you can find one that suits your interests. So just a mention of some of the highlights that I had here at SANSA. So I think the one thing that I enjoy about my job is traveling, of course. So space weather is a global phenomena. So there's an international community that actually works with space weather. So it's not like it's only affecting South Africa. It's a global phenomena, so it affects everyone globally similarly or the same. So for this reason, it's very important for us to have a global space weather community, and this also opens up an opportunity for travel. So when I first started my job here as a space weather forecaster, we underwent training. So we had an opportunity to travel to the UK at their Space Weather Center for a 2 weeks training on space weather forecasting. So this is just us there in their Space Weather Center. And in the middle here, the 2 are my colleagues, Gosnati Masango and Kategile Shivambu, who have a background in meteorology. So they studied not space weather forecasting, but terrestrial forecasting. They worked for SOARS before. And this is Dr. Mpoche Sapungo, who accompanied us there. She's our space weather manager. And this is one of the colleagues there at the UK Met Office. So this was very special for me, I think, because it was my first international travel, and I was so excited. As you can see here, when I was at the Heathrow Airport, I was super excited, to be traveling there. This is just me outside of that facility at the UK Met Office, whilst we were undergoing our training there. And my second highlight was when I had my second international travel, attending a conference in Azerbaijan, which is some country in between Asia and Europe. So it's just between Asia and Europe, called Azerbaijan. So we traveled there for the International Astronautical Congress in 2023. So I traveled with my colleague here, which space weather forecaster Boitumelo Makobe, who also has a background in terrestrial weather. Yeah, so these are just some of the highlights that I have here at Center. So it's nice to know that with mathematics, you can get to travel. I know, yeah, you get a lot of opportunities to travel overseas as well. So just to wrap everything up, I just wanted to mention some of the things that assisted me or helped me when I was also in my high school years. I just want to say you must be determined to excel in your studies. So aim high, aim to improve your results, aim to, yes, to get better marks in your studies. And one thing that truly helped me as well is practice, practice, practice. I know you will hear about this a lot, but it is true. And especially for matriculants, I would say, even for grade 11 students, or for everyone, for anyone for that matter, practice using past papers. I think this is the best way to practice. I think this is one of the strategies that helped me as well do well in my matric year. So using past papers to practice, because it makes you more ready and more confident when you receive your exam, right? So another thing is for you to research your future career. Just learn yourself, learn what actually is of interest to you. And once you find what is of interest to you, then you can decide which career path you want to take. And once you decide on which career path you want to take, then you can start doing your studies or your research on the internet to just read more about it. And also, if you get the opportunity, don't be afraid to reach out to people who are already in that profession. So that is would be my advice. And also just look for opportunities, especially when it comes to towards the end of your high school life, especially grade 12, even from grade 11, just look out for opportunities for bursaries, because I know in mathematics, there are a lot of opportunities for bursaries. I, for one, by God's grace, Tim, I want to thank Dr. Skosana, because she was one of the people who actually, when I was in high school, she gave us bursary forms. So that's how I got to have my bursary as well, through her giving us information about bursaries. So thank you, Sneh. And also just take advantage of any extra lesson opportunities that come your way. I think you're already doing that, and that's a good thing by you joining TTN, which is a good first step. But also just continue to take advantage of such opportunities, like grab them with both hands. Even if it's, I know some teachers in high school do offer afternoon classes and some offer early classes. So just make use of these opportunities, because they would add value to your education or your studies. So that's it from me. Thank you so much for taking your time to join this talk. And if you have any questions, I'm more than happy to answer them for you. Thank you.
Thank you, Ms. Kumalo, for sharing your aspiring journey with us. I think there is a question in the comment section.
Okay.
Okay.
Okay. Oh, may you please read it for me, because I can't see it.
Okay, the question read as, are these flares strong enough to completely change the canonical points from magnetic field?
Are these flares strong enough to
completely change the cardinal points from magnetic field? Or you can
Well,
also check the question on your comments on the chat on the comment
the
section.
comment section, yes, that's
Yeah,
okay.
written chat. Yes.
All right. Okay. Are these flares strong enough to completely change the cardinal points from magnetic fields? Okay. Thank you, Elijah, for your question. The flares, they don't really, so the flares are just they are considered, they are bursts of radiation. So they won't change the cardinal points. They'll just affect the upper layer, which we call the ionosphere, which affects radio communication. So no, they do not change the cardinal points. Thank you for your question.
Okay, I think we can just wait for a few minutes to check if there's no other questions. Other than that, you can take it back to Dr. Skosan.
All right. Thank you.
Thank you.
Okay, I don't see any further questions, so let's end it here for today. Thank you so much, Nundu, for that beautiful presentation. And thank you to all our teachers today and to our chair. So yeah, we meet again tomorrow, bright and early in the morning. And tomorrow we'll be focusing on number patterns. Yes, so bright and early tomorrow. Maybe Nondu, if you're still available, maybe quickly address Ulwandle Nkosi. They're asking, do you have to do masters in order to be able to be a space weather forecaster?
Okay, thank you, Lwandle. So not necessarily. So when I actually started doing space weather forecasting, I was still in the progress or in the process of doing my master's, so I hadn't even had it yet. So I just had an honors. But no, it's not necessary that you need a master's. But one thing about SANSA as well is that they encourage further studying. So SANSA does sponsor or fund their staff or employees should they want to continue their studies. So it is something that is recommended within SANSA, but for becoming a space weather forecaster, you don't you don't need a master's. It's recommended. It will be advantageous, but it's not necessary. Thank you.
Okay, thank you, Nondu, and thank you everyone, to all the attendees and our technical team as well, managing behind the scenes. See you tomorrow, guys.
Bye.
Owen, hi.
Hello?
Yes, okay. I'm not sure if we're still live streaming, but
No, I've just stopped it.
okay. Yeah, I think we are done for today. So, yeah, it went well. We meet again tomorrow,
Yeah, same time, same place.
same time, same place. What was wrong with YouTube? Because I saw what you were trying to like switch it off and on, but it was not showing on the other side.
I'm not sure. I think it couldn't pick up on YouTube, but the ICS guy did. I think he cleared cache from his side, then it allowed us to share. I think feed was not reaching YouTube.
Oh,
I don't know what's
okay.
wrong because we're pasting the link.
So it was a technical issue from their side.
Yes.
Okay, no problem, because most of it was captured.
Okay, no problem.
Okay, see
But
you
we
tomorrow.
also record. We also record. So
I did see email Ngovile has the recording as well.
okay.
That's great.
Okay. Thank you.
Okay, bye.
Bye.
Hi guys.